$140 you can buy this Google Coral development board. It has complete AI built in. You can put it to your camera, and your camera becomes intelligent, much more intelligent than any of these computers. Okay, you can do AI on the little chip. And Google is not the only one. There are 16 other companies that make similar things. NVIDIA has just done. So basically, the future is put these CPU, sensor processing units, into everything. Alright. So we are doing machine learning. Of course, we got on machine learning but long time ago, as soon as we heard the word intelligence. Yeah. Is it just a more powerful CPU or does it have? Okay, the question is this a more powerful CPU or something else? Something else. So basically, if you want to do AI, those of you who are doing AI, they need a GPU. You can't do AI on a CPU, right? And so GPUs are made by NVIDIA, right? So you buy a computer with GPU and bigger and bigger and bigger. So everybody said, why we buy GPU? GPU is for graphical processing unit. And we want to do graphics, we want to do sensors. So these are EPUs, sensor processing units. These are AI design machines. Thank you. Alright, so the AI has a problem. We got into AI, and again, I just don't want to take a standard data set designed by somebody else, put it on a standard algorithm designed by somebody else, and come out with the result and process it again. Okay? However, the problem with that is that the computer doesn't know that what you need expertise to analyze it. And when the result comes out, we don't know how the result came out. Basically, we use synthetic data, we use synthetic algorithms to garbage in, garbage out. So ML, which is machine learning, is a black box. And that means that we really don't know what happened inside. Just they told me that 99% accuracy is there, but I don't know why it's not 99.5. If there is bug, they don't know that there is a bug. Alright? So, basically what we need is explainable AI. That when you get a result from the artificial intelligence, you should be able to explain it with manual intelligence. Okay? If you cannot explain it, then military cannot fire a bomb based upon your artificial intelligence. Okay, nobody can take a decision based upon AI, a big decision, without backing of the intelligence. So that is what is happening. Is explainable AI. Second problem is imbalance. The real thing that we are looking for is things which are very rare. So I asked my university to give me data, and they said, no, you can take all the data from our thing, and so they give me billion packets, or maybe billion packets. And there's one or two attacks in the year, so they said, okay, there's one or two attacks. Current AI cannot learn from that. Current AI gives thousands of attacks to learn. They're still not intelligent, believe it or not, but DARPA, the Defense Advanced Research Project Agency, has said that current AI is 18-month-old child. Okay? To 18-month-old child, actually it is not 18-month-old child yet. To 18-month-old child, so one cat and one dog, just one. And it will remember it forever. It will distinguish them correctly forever. So one AI machine, so one cat and one dog, it will totally be different. It needs to see 1,000 cats and 1,000 dogs. Alright? So we need something which is more intelligent than 18 months old. And that is the goal, my team. Go to the AI website and that's how you find it. Alright. So the next issue is, okay, AI is going to be happening. Then why are we behind in networking? Everything in my home is intelligent now. Now the question is, so why is network not smart? Network not intelligent, network is smart better. It is not intelligent. I cannot talk Alexa to my network, to my router. Alright? So that's what people are saying. Let's make it run by itself. That is called self-driven network, SDN. Okay? It's a play on the word SDN. Self-driven network. What is that mean? create a network. For them, you don't have to have a DSCP server. You don't have to program a DSCP server. They will recognize where they are. They will get the addresses. They will configure. They will find out who is not working. Self-manage, self-discover, self-monitor, self-diagnose, and in fact, OpenAI project under Linux Foundation again. I'm not sure about that. Yeah, Linux Foundation again. It's working on network intent composition. Network intent composition is simply the idea that you tell the network what you want to put in English, and it will figure out all the things that are in Okay, all right. I'm reading out the last word on quantum. So quantum is happening. Okay, last month in October 2019, Google announced that it has achieved quantum supremacy. What does quantum supremacy mean? Quantum supremacy means that can you do something with quantum that you cannot do with ordinary computers? And so, yes, they found out a way to the problem, and it cannot be done even given infinite time to become a computer. And for that, they designed a computer, is shown here, 54-bit, 54 qubit. Qubit is quantum bit. It's different than the 54 bits of the other computer. And I have a whole lecture on quantum again, because I will not go here if you want, you can go to my lecture class. And everything is recorded, including this lecture is being recorded. Everything is recorded, online, video, audio, everything is there. Okay? So basically, everybody is competing. China is competing to be one first. USA is competing, Japan is competing. All of these countries whose name are there have a quantum computing research program. Okay, I'm not sure about India, but I'm just saying that this is where the world is going. All right. Now, why is quantum so important? Because one thing that has been known for a long time now, 10 years, that with quantum you can capture large numbers very easily, and most of the cryptography today is based upon not being able to capture large numbers. All public cryptography, all certificates, they're all based upon not being able to capture. But once the quantum comes in, you'll be able to capture very fast, and all your secrets will be gone. Tomorrow, my friend, I'm sure we will talk about what else is happening in that area. But basically, that's what the government is afraid of. So they already started working on it. Now, if you want to play with quantum, you can do this sitting right here, there you are. Because there are many simulators available to write from quantum programs. Again, you can go back to my lecture, you can go back to any book. There can be a book on quantum, and you can write quantum programs today, even though you don't have hardware. But yes. That brings you to the end of my talk. So these are the 13 things we talked about. SDN is not happening. What is happening is this aggregation. Instead of black boxes, we have white boxes. Instead of controlling people, we have orchestrating people. While in the cloud, we have microcloud. From the core, we have moved to edge. For services, we have microservices. And then orchestration of switches, fast. Now, cloud is the one. Instead of virtualization, we are doing containerization. Instead of standards, we are doing open source. Instead of centralized, we are doing decentralized. And then instead of smart, we need intelligence. For AI, we need scalable AI. For managed, we need self-driven network. And for classical computing, we need quantum computing. As a result, now this is what the problem I'm facing and what all of you are facing, that I cannot get a student a PhD in 1 year. Right? And then 4 years, 5 years, 6 years, and if they keep working on the same problem, if they started on, let's say, on cloud, 5 years, 6 years later, it won't be any good. I'm telling you right now. So what we teach them is not in multi-cloud, we teach them how to become expert very fast in a year. Okay? And they become an expert on one topic and the next topic and the next topic, and they know how to do research, and then they become the expert in research. Okay? Not on a topic. How to find new information, and that's what we need. Because information is available, it's just how to try all that is a new idea. And for impact and success, second thing is that publishing is not sufficient. Now really we want to get it there so that if you want to get it there, you go to standard bodies. And I went to standard bodies. So presenting by research so that they can adopt it, and they did adopt it, like many were mentioned here in one of the course. But now, if I want to do something, I just go to GitHub, put it on public domain, and let people use it. Okay? That's the end. I have lots of paper stuff. I am not going to go through them, and here are the slides. If you have your phone ready, just scan this slide will come down depending upon how much they can load, they can take. Alright? Now, based upon that, and if you don't have a network, you can just take a picture of this slide and scan it. Alright? Now, any questions? Can you leverage the concept of IoT? Biochips. Alright. So the question is, can we leverage the concept of biochips? The answer is, I don't. I have my own limitation. And I don't know via bio. Yeah, go ahead. Fast computing. Okay. Question is, what is the difference between fast computing and edge computing? So basically, people really don't know where the edge is. Because in the old days, basically there was no edge, but basically edge started from the telephone company city office. So if you did something in the city office, previously they did not do any computation in the city office. That was called the edge. Then it moved to the, now it's moving towards the towers, 5G towers will have some computing. Then it's moving to your phone, that your phone itself will have significant compute capacity, so that's the edge. So right now when you publish a paper and say that edge computing I'm doing this, you don't know whether they're doing it in their phone or they're doing it in the tower. That's the edge. And then the edge will move everywhere, and then it's technically then will be called fog because it's everywhere. So it's just a gradual migration. Okay. Any other question? Yeah. Yeah. Okay, how do you differentiate smart from intelligent? This is very simple. If you are connected, you are smart. So everything that is being sold as smart today is matter. Everything that is being sold as smart today, and you can buy smart everything, smart computer, smart. Everything that is on my list is smart. All they have is a connection, internet connection. All they have is a Wi-Fi. Very easy. Here is smart refrigerator, there is a Wi-Fi. And intelligence is AI. So if they have intelligence, so for example, if you buy intelligent cameras, and many of them are available, they can recognize your face. So when you come to your home, they will open the door for you. And if I go there, they will close the door for me. So because they can recognize my face, that is intelligence. Right? They have to talk to teachers by some AI. So similarly, the cars and everything else will be intelligent because they can go more than the beyond your still intelligence. Okay, alright, so if there is a definition which I don't know, but basically this definition is that if you design something for X and then it does more than X, then that is intelligent. I wouldn't argue about that. Okay, is intelligence equivalent to adaptable? Yes, in some sense. However, the adaptation that we're talking about is somehow getting beyond our imagination. So, if we do simple adaptation, that people will not call it intelligence anymore. In the days of AI, when you see AI apply to some problems, you cannot talk about simple changes here. Right? So the adaptable thing, yeah, but again, it's really right now they're looking for bigger things. Right? Self-driving car is an example, they are intelligent. Because can you imagine that the car can see that there's a dog or there's something else on the road, and the road sign is missing or there's a building. That is much more than the simple. Yeah.
Sir, you said that instead of publishing, is it we have to go for putting it on in open source?
Okay, so instead of publishing, no, I didn't say instead of publishing. You can't publish on that delete. I mean, and you want to get promotion. So you have to do that. But if you really want to impact the world, communication is the first step. The real step is to change the world. Right? The goal of everyone should be to change the world. You want to leave the world better than what you came in. Right? When you came in, the world was like this. Now you want to leave it here. That is what the goal of every life is. And if you want to change the world, publication is probably the first step. And I wouldn't just give up on that. And otherwise, I'm not publishing. But you won't get anything. So publication is required. But I think if you really want to, in fact, you want to see adapted. So the thing is, the way we measure publication is by citation. If the paper is cited by 2,000 people, it's a good thing. And that is the kind of thing, that if it is adopted by 2,000 companies, that is a good impact. Right? So it just depends on how far you want to go. Yeah. Sorry. I hope somebody keeps track of time here and please let me know if you can start the question. 15 minutes. Yeah, 15 minutes. Oh my God, my time was fast. Your timer was set for 40. Oh, there's still 9 minutes left. Okay, I was not reading it right. Okay, go ahead. Ask all the questions.
What exactly is?
What exactly is? Oh, what exactly? Okay, so you can hear okay, but we just published one. Explainable AI means that whenever you get some result from AI, it's very difficult. But at least in some cases, I can explain. So I can take we take 2 million whatever, right? Data point, and it feeds to AI, and it comes up with okay, all right, so there's something, some answer, something. Then you take 1 point, you feed to the AI, and it says, yeah, this is an attack, and you feed it to another model, which is most of the time it works, and it says the same thing as the AI. So I can justify that, yeah, I think there's no bug there. Explainable AI. You can explain the results of AI. Otherwise, AI is something that only machines can understand. People don't.
In building multi-clouds, can you hear me?
Yeah.
Building multi-clouds, so the cost is more. Because we need to make it more security than the single cloud. So for that, is there any single autonomous system to make that multi-cloud, or different clouds are built on the same cloud?
No, okay. So the question is, doesn't it cost increase the cost to microservices? The answer is no. Basically, right now there is no autonomy. Basically, as I said, network is actually manually developed and manually deployed and manually everything. Autonomy is not there. But if you go to Netflix, or if you go to Facebook, those people, every programmer is designing a microservice. Okay? Microservice is very easy to design, to code, and to test. Okay? It has a very specific API. This can be tested, and now once it is tested, anybody can use it. So it is actually much easier to develop a microservice than to a what you call a macroservice, big thing, right? Because you cannot test forever, right? So that way the cost of development is lower. Now the deployment is the same issue. Is that basically deployment is all automated. Yeah, right. The deployment is automated. So while deploying, you don't nobody thinks about anything. Machine just figures out what you need. Okay, any other question?
So you made a very interesting statement. If you want to understand one cat and one dog, and the machine needs also to dog to understand.
Yeah, I'm not hearing now. You think that's problem. Go ahead. Yeah.
So you made a very interesting statement that if you want to understand that
Yeah.
one cat and one
Yeah.
dog, and the machine will also understand that.
Yeah.
It's true. But now you are coming to it, right? I will
Yeah.
AI.
Yeah.
But there also have given expert system and expert comes after
Okay.
that. So can we have some human talks into this kind of thing, or human or maybe community?
Yeah. Yeah. I think the question is whether in explainable AI really brings the AI and the human together, because human cannot understand and we can't. Right? It's just explainable that I can understand, right? So yes, the answer is yes. Basically, that is what is happening. Is that explainable AI is bringing the human back into the AI. The AI will do most of the work, millions of packets, millions of data sets, but few of them man can do. they will develop. Yes. Now, if you can do that today, you go to DARPA, please, I'm joking here. They are funding MIT and UCLA and all those big universities. What exactly can issue? Can you make AI which is 18 months old child? And this is written on their website. Just go to the site, just search Google for AI plus site DARPA.gov. Okay? And you'll find their whole charter. Their charter is explainable AI. Yeah. Yeah. So I think in this morning, said that you think it's previous security were all based upon boundaries. So you put a wall around the campus and you're all secure and wall is there, right? Now, inside the campus, there is people and that. So the idea is that wall cannot do anything. Right? And so, and what is happening, every domain, like this domain, this is one environment, 100 people that from 100 different countries, 100 different places, they are untrusted domains. Right? And so when you have a group of untrusted entities, how do they work together? That's where blockchain comes in. This is our theoretical, because for every single application you think, or you use blockchain here or untrusted domain. That's what blockchain is about. Blockchain is basically anybody who does not have anybody out. Okay, I question was, can you do data fusion with blockchain? Data fusion. Oh, this is our paper. So I think your question is that how are we going to move from data fusion and that's what exactly our slide on probabilistic blockchain is about, that we take decisions from thousands of people and then we fuse them into one decision. And actually we use AI for that. So the thing is, that is basically what we are saying is that we take what was before information and make knowledge of it. Information and knowledge transfer. So that is what we are doing, I think. But there are so many issues with that. And the issues are everybody has reputation, everybody needs rewards. There are many problems. Yeah. SDN is valid. Yeah. Okay, now the question is, no, that is not right. So let me explain. Your question is, SDN is about orchestrating, and the orchestration is automatically doing everything, right? Yeah, no. So there are two SDNs here. Self-driven network, SDN, which is just starting, is automating things. The previous thing, the software-defined networking was that previously it was very difficult to change things. Every time you want to change, you have to go to Cisco and ask them, please change this line. Right? Now with white boxes, with transparent everything, with disaggregation, we can do it ourselves. So it doesn't mean that we automate it. The orchestrated means that I can change 1,500 routers in one command. But that is not automated. It is automated, yeah, of course, all thousands here. But I have to manually decide. The automation part is coming now in self-driven network where somebody from the IIITM will figure it out that this is what you want to do and do. The automation is separate from yeah. The question is, now let me repeat the question. In question is OSPF can figure out what is the optimal route. So what is new here? The answer is running OSPF is not really easy. Okay? There are many parameters that you set. If you have a single router in your home, you have to program your DHCP server first before you give out the address. That manual part is what is bothering us. Because if you go to a doctor's office, doctor says, I don't know what is an IP address. How do I figure it out that I have to put in 198.168.10.1? What is all that? So the doctor cannot use it. Right? So everything is automated but unused. Alright.
So I saw one of the paper that reputation is
I will come to you because yeah.
my question is on the reason about reputation.
Established blockchain reputation. Yeah.
So in that particular scenario, you are establishing the reputation of the persons who are giving the lecture.
Yeah.
So these the person's identity is known. So the persons who are giving the identity, giving the lecture,
Yeah.
their identity is known to you or it's
Okay. So the question is, in the probabilistic blockchain, is the identity of the person giving you the opinion is known to you? The answer is yes and no. In most of the blockchains, such as in Bitcoin, we know the ID of the person who bought the XKD from me, but we know only their serial number. There is a number that they have decided themselves to give it to themselves. So we know that ID. So I know that I gave it the serial number 5,000, whatever, this much money, and they will give me right? So we know the ID. In many cases, the ID is related to a physical person. And that happens every time you cross the virtual domain to physical domain, and the crossing point, the police is standing right there. When you buy the Bitcoin, I bought the Bitcoin actually last week. They took my credit card number, they took my driver license number, everything else. So now that number is useless to me. That number is basically I have a number and I have Bitcoin. But that is totally well known. If I buy 1 kg or something, government will know.
yeah. But the thing is that you are associating the reputation risk. So the identity is not known to you. So how will you?
No, so we will assign reputation to the number.
Sir, my question is more generic.
Yeah.
When we talk about this blockchain, we have a process of computing. So it requires huge computation, hardware resources.
Right. And let me repeat your question and I know what question. In the Bitcoin, there is a process by which people who do the collection of all the transactions, they are rewarded. They are rewarded by their letting them print some money. That is called Bitcoin. Mining. Right? But that is not necessary. The many of the Bitcoins, and I don't want to go into Bitcoin lecture right now, but many of the blockchains do not have that algorithm. They have simpler algorithms, which do not require solving a puzzle. Right? So that's all is our work. So people have done some work and one can do research on how to simplify that. And people have done it, and for 15 years, a lot of people have put a lot of money in Ethereum and this and that. We talk about all of these chains. Everybody has their own algorithm, their changing algorithm, all the time, right? The whole different problem.
I just wanted to, I'm curious.
Yeah.
It will generate a lot of carbon footprint. What will be the environment?
Okay, so the question is, you have to do all this computation for Bitcoin. For Bitcoin, I don't want to clear, blockchain is not Bitcoin and Bitcoin is not blockchain. This is the same thing as ACN is not open source. Blockchain, Bitcoin is blockchain. In the blockchain, they use a particular algorithm which requires a lot of computing. That is the carbon footprint we are talking about. But you don't have to use, you can use blockchain without using that algorithm. Right? You want to Bitcoin, because Bitcoin is already running and working and everything else. So nobody will let you change it. But there are other blockchains that allow you to keep. Alright? Okay. One more, the last one. Okay. All right. Let me just, I didn't understand fully, but let me please take the question. The question is, and it is related to plastics, right? Okay, so I didn't send you a database. That was the thing. Yeah, right. I'm sure there are plenty of people in database, and I'm just going to guys. So I ask for that.
Okay, I think we are ready for lunch.
Everyone has to learn how to become an expert on a topic. 1 year today, 10 years later, you need to become an expert in 1 week. 1 week.
But this is the advantage of Google. Information is easy to get. In my days, when I was doing a PhD, it used to take 3 months to get a paper. We used to write to our library. The library will write to some other library. They will have a hard copy of the journal. They will copy it now. Now, in second, I get the journal. So getting a paper is not very difficult, right? Reading a paper is not very difficult. So what do you do for 4 years?
Okay, we'll be breaking for lunch. I hope everybody will be back by 1:30. We'll have another session on machine learning and digital light communications for autonomous and electric vehicles. Oh, I'm sorry. It will be a keynote. I'm sorry. It will be a keynote on research in medical imaging, processing, and informatics by Professor Jayanta Mukhopadhyay from Indian Institute of Technology, Kharagpur. So the lunch will be served in the block next to this building. The volunteers will guide you there, and you can be back by 1:30. Thank you.
No way.
വളരെ കുറച്ചുകൂടെ മറ്റേ ഇവിടെ എസ് പിയിൽ ഞാൻ സാറേ ഇങ്ങനെ കുറെ പറഞ്ഞു കാര്യം അതായത് ഊഴെടുത്ത് എസ് പിയിൽ മറ്റേ കിടക്കുന്നുണ്ട് അവിടെ എല്ലാം എടുത്തിട്ട് ഞാൻ കൂപ്പുണ്ട് അതായത് നമ്മൾ കടയിലുള്ള കൂപ്പുണ്ട് അവിടെ ഇല്ല പറഞ്ഞു അപ്പോൾ ഫ്ലാറ്റ് എടുത്ത് വന്നു അപ്പോൾ ജോൺസൺ കൂപ്പൺ കിട്ടിയോ ഇല്ല സാർ ഇത് ഒന്നും കൂടെ കവർ ഇട്ടുകൊണ്ട് കവർ ചെയ്യുന്നത് നമ്മൾ ഒന്നും കവർ ചെയ്യും പിന്നെ ബാന്ധവം തിരിച്ചെടുക്കും സാറൊന്നും ഒരു കാര്യം പിന്നെ സാധനം റൂമെല്ലാം കുറിച്ച് അത് 10 മിനിറ്റ് 20 മിനിറ്റേ ഉള്ളൂ ബെഞ്ചിന് താമസിച്ചു താമസിച്ചിട്ട് ഞാൻ അതിനൊന്നും താമസിക്കില്ല ആവശ്യക്കാരൻ പറയുന്നില്ലല്ലോ നിങ്ങളുടെ
നീ പിന്നെ ആവശ്യക്കാരൻ പറയുന്നില്ലല്ലോ, നീ എന്ന് പറയുന്നത് ഞാൻ കേട്ടത്. അത് അജി പറയട്ടെ,
Yeah, so I cannot do this. Like, I mean, one. People think that I know about condition control. I use. I know. I know. So the thing is, yeah, a lot of people sometimes think, but right now I'm concentrating on things that is right. Yeah. So you really have to think about it. Oh my God. Yeah. All right. Thank you. Thank you. I have a lot of discuss on the table here, right? I will come to it.
ഇതിന്റെ അടുത്ത പരിപാടി എപ്പോഴാ? 1:30. ഹലോ ചേട്ടാ, ഇവിടെ പരിപാടി കഴിഞ്ഞു. അപ്പൊ എന്ത് വേണം? ഓ, ടെൻ സ്ക്രീൻ കൊടുക്കട്ടോ. അത് അങ്ങനെ തന്നെ കിടന്നോളാം. ആ ആ ആ ആ ഓ അതാ ആവുമ്പോ മറ്റേ
design.
മിക്സിംഗ് ഉണ്ടാവില്ല. ഞാൻ ചോദിച്ചു ഏജ് മാത്രം മിക്സിംഗ് ഒന്നും ഇല്ലാതെ കൂടി കൂടെ കിട്ടിയാണ്. ഞാൻ ഓക്കെ പറഞ്ഞു പ്രശ്നം ഞാൻ പറഞ്ഞ കറക്റ്റ് ആണോ പറഞ്ഞു ആള് കൂടിയോ ജസ്റ്റ് ഔട്ട്പുട്ട് നമ്മുടെ കാര്യമില്ല. കറക്റ്റ് ആയിട്ട് ഇവിടെ എത്ര CFM ആണോ മെഷീൻ ഡിസ്പാച്ച് ആ CFM
ഇല്ലടാ ഞാൻ വിളിക്കാം, ഞാൻ പുറത്തേക്ക്
ഇത് എവിടെയാണ് രണ്ടിനും കൂടെ ഒരു ഏഷ്യോ അതിന്റെ കൊണ്ട് ഓർമ്മ ഏരിയ മിനിമം 33 ടണ്ണെങ്കിലും 21 ടണ്ണ് വെച്ചിട്ട് നീ
രണ്ട് റൂം തണുത്തില്ലാന്ന് പറഞ്ഞു അതാണ് തണുപ്പ് കുറയാനുള്ള കാര്യം 33 രണ്ട് ഏജ് വരുന്നത് മോട്ടർ തന്നെ കൈകാര്യം മോട്ടർ നോക്കുന്ന ഒന്നും നോക്കുക അതിന്റെ കറക്റ്റ് കണ്ണിൽ സീറ്റ് മാത്രം നോക്കിയാൽ അത് നമുക്ക് മുമ്പ് 21 ഉള്ളൂ 2 റൂംസ് ഒരു രണ്ടെണ്ണം 5000 സ്ക്വയർ ഫീറ്റ് ഏരിയ തമ്പ് റൂൾ ഡിവൈഡ് ബൈ 125 നിങ്ങൾ ഇരിക്കുന്ന 20 പിന്നെ എങ്ങനെ സഫീഷ്യന്റ് നിങ്ങൾ എങ്ങനെ തലകുത്തി ബാലൻസ് കയറി കിട്ടും
അതെല്ലാം ട്രീറ്റിട്ടാണ് എടുക്കുന്നത്. ഞാൻ സൈഡ് അറിയിക്കാതെ എന്തിനെ കൊണ്ടോ ഞാൻ പറഞ്ഞു. അല്ലെ നിന്റെ ബാഗ് ഓടണമെങ്കിൽ ഓടി, എന്റെ ബാഗ് എടുക്കണമെങ്കിൽ കുഴപ്പമില്ല. അല്ല നിന്റെ സാധനം കയ്യിൽ ഓടണമെങ്കിൽ ഓടി, ഇനി എന്റെ ബാഗ് എടുക്കുന്നു അത് ഞാൻ പഴയതാ. അതില്ലാതെ സാധനങ്ങളൊക്കെ കൊണ്ടുപോകാം. ഇല്ല അത് കത്തിച്ചു അമ്മ കത്തിച്ചത്. അത് സംഭവം അന്ന് നേരം എടുത്തിരുന്നില്ലേ, പിന്നെ അമ്മ അതിന്റെ കളർ ഉണ്ടാ പിന്നെ ഒരുത്തിന് കൊടുക്കണം എന്ന് പറഞ്ഞുകൊണ്ട് അതെടുത്ത് കത്തിച്ചു. നീ അപ്പൊ ഇതെടുത്തോണ്ട് എപ്പോഴും രാത്രി കൊണ്ടുവന്നാൽ മതി. ഓ ഒരു 3:30 വിളിച്ച് പറഞ്ഞാൽ മതിയല്ലോ. ഓക്കെ ഇല്ലേ ഏട്ടൻ? ഇല്ല ഇതുവരെ ഉണ്ടല്ലോ മെയിനായിട്ടും കിടക്കും ഇനിയും കിടക്കാണ്
So speaker is Dr. Jayendra Mukhopadhyay, IIT Kanpur, sorry, IIT Kharagpur. So he spoke it's on the research and implementation. He is a BTech and MTech and both with the PhD in electronics and electrical communication engineering from IIT Kharagpur. And then he joined it in the same IIT Kharagpur as a faculty in 1990. Then I think now he serves as a professor the same institution IIT Kharagpur. Within this time, he is also a Humboldt Research Fellow at the Technical University of Munich, Germany. That's in the year 2002. He also held short-term visiting positions in University of California, Santa Barbara, University of Southern California, and National University of Singapore. And his main research interests are in image processing, pattern recognition, computer graphics, and multimedia system. I think many of you are doing research in the same area, so we can expect more questions also from this area. And he has published 50 research papers in journals and conference proceedings. And he has also received the Young Scientist Award in Indian National Academy in 1992. So he's a senior member of IIITM and the National Academy of Engineering. He is also for patent two-part synthesis based method and systems for VDP signal analysis. So a great person, and we are very privileged and honored to get you in CoCoNet' here, Dr. Jayendra, and hope you will have a very wonderful talk. Yes, sir. Hello.
So, thank you, Doctor. And we really to be here. I thank Dr. Shabu and the organizers to invite me in this forum on sharing my thoughts. Particularly, some of my research is what I'm doing, and I would like to summarize my experiences in that. Basically, just about starting research in these areas, medical imaging or medical image processing or clinical informatics. Many times, no, I always encounter students who are very much excited and passionate about going in these areas. Of course, there are various issues, various challenges going into the research problem. It's a good intention and also your passion to do something good for the society for healthcare. But as you know that while seriously taking research issues, we need to have to take care of these other factors. So I will just highlight a few of them, which I feel is quite pertinent. And also I will present a few case studies of my research without going into much details, but around those issues, what I faced while doing research. So as you can see that there are two terms I have mentioned here. I considered medical imaging and then processing is basically medical image processing and informatics, medical informatics. So let us have a brief distinctions about these terms. So they are quite related, but again there are a few characteristics of these terms in the research community as we accepted. The definition of medical imaging, as you can see, that it is just not any kind of imaging of related to the healthcare. It is particularly defined with respect to non-invasive visualization of internal organs and tissues. And images could be in the form of two-dimension or two-dimension, can have high-dimension images. Major modalities which are covered in this domain, they are quite active instruments, and you take the images of internal organs in a non-invasive way and then you do different kinds of investigations. So you see that there are different technologies and principles which are used. So like you have X-rays, X-ray computed tomography, nuclear medicine, where position emission tomography or position emission computed tomography, and then ultrasound, magnetic resonance imaging. So there are various instrumentations. I will just give overview of what are the different characteristics of particularly images of these modalities, and with that we will also consider compensation. So this is an example of X-ray image, and you can see it's a two-dimensional image. At this side, this is the two-dimensional image, whereas the other one is a cross-section of the three-dimensional image. And you know that there are different purposes for imaging. So it is not that one is powerful than the other, because what is the context based on which you have to apply a particular imaging. So when you are talking about two-dimensional imagings and where you can see the bone structure very easily, and of course it's a two-dimensional projection, there is a limitation, but those are the things that are diagnosed using the X-ray images. Whereas in 3D tomographic reconstruction, you can get the internal organs within that body. Suppose there is a mass of tumor, there is a mass, and that can be detected well and with its three-dimensional configurations. And ultrasound imaging is another modality where you use ultrasound signal and it gets its reflection from the target, and you get the images. And I'm not going into the details of imaging principle, but and there is also another variation of ultrasound imaging where you can use the Doppler principle of finding out the frequency shift of your projected ultrasound rate and compute the velocity of the target. And particularly, this is used for observing the dark flow, and which is otherwise not visible using ultrasound imaging. So this is another typical case, and in magnetic resonance imaging, once again, soft tissues are mostly investigated, and they are still visible. And as you know, the principle here is that you are trying to bring the particularly hydrogen ions from its excited state due to magnetization to its native state, and during that time it emits certain frequency of electromagnetic wave, and that has been detected, and you can control also over the direction of this particular polarizations or the directions of these magnetizations. So you can use tomographic scan, and you can get three-dimensional images. So these are a few examples where you are having the anatomical informations of our body, of the internal organs. But we would like to know also what is the physiology behind it, how the physiological function is going on, and there are different functional imaging techniques by which you can find out what is the process going on inside the organ. And typical example I have already given, like Doppler imaging of ultrasound, which is a kind of functional imaging, where you observe the blood flow and you find out how it is functioning. But classic example is of functional imaging is of understanding the functions of brains for different activities. And not only brains, there are other kind of things like metabolisms in our organs, and to find out the state of metabolism at certain control conditions. So nuclear medicine is one of the modalities where you can observe this kind of metabolic actions of different molecules. For example, here you need to follow certain protocol. Like in a patient, first you have to inject dye of certain radioisotope, and of course that is attached to some glucose complex, and then that gets metabolized back to deposited after a certain duration. So it may take about 2 hours, 3 hours duration. So there is a specific protocol the physicians have to follow, and then after that, from that radiation, from that isotope, then you detect the radiation. So positron emission tomography, it is based on this principle, because the emitted positron, it collides with the electrons and then emits photon. And there are similar technology like single photon emission computed tomography, where if you just consider multiple views of photon emission, like X-ray projections, so you take from multiple views and then you reconstruct it. Or there are also an advanced technology where you can associate directionalities. You can have a circular detectors. So these are examples of the SPECT scanner, and you can have, as I say, the different views of the corresponding organ where these metabolic depositions have been taking place, these metabolisms are observed. You can study them, or you can have a SPECT scanner where for a single collision there will be 2 photons emitted, and it will travel in just 2 opposite directions, and the simultaneous detection of those photons can reliably observe, can give a reliable observation of that phenomenon. In this way, you can get a very high resolution image and spectrum. So some of the and also there are instruments where you can observe both the anatomical and also its functional features by the same instrument nowadays. Which is, of course, nowadays means at least with technology. and you did, and that has advanced this particular research in these areas and capabilities of detections and other things for the physicians. So this is one example where you can see that there is an anatomy. I mean, it's an image of the anatomy, and then this is the fake image, and this is a pseudo-colored fake anatomical images where we superimpose, and there are certain color codes by which clinicians will understand the state of the video of the patient. So I have given some examples, but there are different other modalities also which falls in this category. So let me then summarize that what could be different research motivations in this particular area of medical imaging, where you are working with this advanced instrumentation for observing the functions or anatomy of our bodies in a non-invasive. Now, as you understand, that technology is one of the primary goals. So, how to improve the imaging part, like you mentioned some new imaging techniques and technology. So, this is naturally one of the key movers in this area, and it is very difficult to get associated with this kind of research initiative unless you are in that research group who are actively pursuing this part, and it needs to be associated with also all the medical imaging instrumentations, higher research organizations. Invention of new imaging protocol, that is another interesting part, where you have the machine and clinicians, they use it for the presenting for certain tasks, but there could be many other uses of that particular machine. Now, whenever you are doing some imaging, as I have given the example of nuclear medicine, there is a protocol by which that imaging has to be taken, has to take place. And so, how do you design an optimal protocol for certain purposes? For example, which dye you should select, which radioisotope you should select, which molecular complex you should select, and to observe certain phenomena. Not only that, now how many hours and what are the dependent factors? So there are various issues are involved, and sometimes many of the researches they are directed towards addressing those questions. So that is the context in that case. Of course, diagnosis of disease is one of the prime mover in this area. So usually, expert radiologists or physicians they use by their experiences, by training, but there are a lot of subjectivity, those are also there, and also a lot of challenge that everything is very clear from the images. And there are various contexts because the human body, so I'm talking about the human body here because most of the things that we are related to the human, we can extend it to other cases also. But the thing is it's a very complex. There are so many different varieties, variations, and not every case can be tackled with a particular type of. So that is why it is. There are always cases which are very much challenging, and those are the cases for clinicians who are using those instruments. They do know, and if you interact with them, then you find out what are the problem cases and whether really your research can help them. And also that can help them in reducing their involvement or engagement with the instrument, because it takes a lot of time to understand a particular phenomena from the images sometimes, and so can you do it a bit automated way so that sometimes expert clinicians engagement will be reduced. So there are various issues like this in this case. And detection of organs, that is part of the another research problem of automatic detection of organs, which will help the clinicians and others with particular area localizing. Formation of atlas from population, that is also one of the research problems area of research. And particularly for different organs, there are you can take images and there are different signatures, so radiomic signatures for certain actions. It could be any other kind of signatures. It is not always that images are, as I was mentioning, it is not like images are like optical images. So there are these are the signatures for different physical phenomena. Now, how can you consider certain set of signatures or those images which can act as a normative template for the normal population? So that is a kind of motivation for forming an atlas. And if you can, then of course, if you have any other image, you will try to observe the deviations from that normative template, and then you can use it for the purpose of diagnosis. So this is one area of research is monitoring, intervention, and therapy. So this is also kind of I should say another directions where using the image guided or using the images can you improve the treatment plan? Can you design a new intervention protocol? Or while you are giving a therapy, for example, for cancer patients, you can give radiation as a therapy. And radiation, it's a kind of a 5 weeks, 6 weeks after. And through that period, if you can observe those images, if you take those images and if you find some, whether actually you consider that your outcome of your therapy would be positive or negative. So this could be some of the problems here. Prediction of outcome, that is another related thing. I told already an example of radiation therapy. So this could be also another research topic. So there are various such issues. I have just highlighted a few research topics which I felt quite important, but I might have missed also because, as I mentioned, it's an area which has various diverse requirements. Now, let me then point out this medical image processing part. Once again, from a very general perspective, I would also highlight some of the research goals and objectives of medical image processing. Here, the image processing is a major task, and all your objectives are set around processing of it. Where, as I mentioned in medical imaging, you see that there are many other issues which may not be directly, which may not directly become image processing. Or image processing is subtask in that. So, and also, it not necessarily means that you are processing images from medical imaging. So that is also another consideration, because it may be other kind of modalities. For example, digital microscopy. Digital microscopy usually we don't put under medical imaging context because it is not really kind of a non-invasive way of looking at the medical organ. That is the basic definition. So naturally, digital microscopy is a pathology, is a large domain, is a very active area, where image processing is very much used and required for inferring about disease diagnosis. Then not only that, we can define, we can use normal images, digital images or videos to solve many other problems of healthcare. I will give one example of that which we work on, and use it for in this area, which also can be put under this. So, as I mentioned, the objectives should be set in the context of processing. Of course, image processing is the primary task, as I mentioned, and there could be various various normal image processing objectives that could be set under this. For example, denoising, so to make the image more clear and remove certain kinds of noise which can contaminate in that particular premises. Restoration, registration, function. So I'm not defining each and individual problems. If you are already doing image processing, you know what kind of objectives are there. Feature extraction, segmentations, these are usual image processing tasks. And that is mostly, those can be used for building models, like you can design classifications, you can perform regulations. So these are the model building tasks So what are the problems, once again, what are the challenges in this, while formulating problems in this particular thing? First thing, so it is actually the medical use person or medical use is what I'm considering, or I should say that it is the overall challenges in the overall domain, like medical informatics, which may not consider imaging as a particular modality. So that will be various other kind of information processing. But as you can see that this area requires, it's a collaborative and interdisciplinary research. So it requires, I mean, it's a, particularly, you have to collaborate with the medical professionals and doctors. And that kind of your research team should include experts from the other department. I'm talking about from the other domain because I believe most of us are not from the non-medical professions. So from the engineering professions, and when you are really doing research, you should think about that. If you do not have that kind of collaboration, it is very difficult to do exciting and interesting research. So that is one kind of requirement. You have to understand the domain and so you should be ready to also read biology and read all contextual part from medicine and other things because you have to talk to the physicians in their languages, not exactly in their languages, but at least where the bridge should be, there should be the gap should be bridged by your additional strategy. So and understanding is very much important. Otherwise, you cannot define a research problem. So as per your own way, you have to assimilate that. Feasibility. So the first two things also the part of feasibility, but you should seriously think about feasibility. You can have a very I mean, very ambitious project. You can think that you will cure the cancers with say 99% accuracy. You may detect something like that. You can set your objective, but you should know the state of the art and you should find out whether it is feasible given the resources and given the constraints you have at your hand. So feasibility you must study. This is another thing when you are doing research, you should see that there has to be some institutional body for permitting doing the research. There is ethical clearance, and whether that should be from your institutes, from where you are carrying out the research, and also from also from the hospitals where you are doing. So, in absence of them, because many times you will find it is very difficult to have that kind of body in your organization, but you should be very clear that you should have it. So, including the issues. Data collection and annotation is one of the prime tasks of this research from our point of view, from the engineering perspective. Because nowadays, as you understand that most of the techniques are data-driven techniques, and even it is very empirical. This field is also very empirical. To collect data and to annotate data is a very important task. Many times we miss it. I mean, when the researchers, when my students they come, they think that data collection and annotation is a kind of it's not a very interesting research topic. It's not good for publication. It's just they are doing because they have to do something. But no, you have to take care. There are a lot of steps, a lot of systematic way you have to do these things, and definitely that is a contribution to this area that you should do. So while doing these things, we may take care of these particular things like anonymization, archival, and because you see that one of the major problem of doing research in medical imaging or medical image processing is that sharing of data, because we maintaining the privacy and confidentiality of patients. Sometimes the data has to be in the research group, and that is the kind of conditions from the ethical clearance committee or institution and board. So naturally, if you like to share the data, you should think about all these aspects of anonymization, and then how to archive them, how to make it open access to other research communities, because then the research will be more can share your ideas with others, and that would be contributing in this area. You have to have your research plan and methodology. So I'm not. So statistical analysis is another thing that you need to take care of. So without carrying out the statistical tests, you should not come to any conclusion. So that is why the data, amount of data is very important. And many times in this research, it suffers from just the volume of amount of data. So any conclusion, it has to be carried out with proper rigorous statistics. And there is a requirement of longitudinal study in many cases. And whatever you do, particularly when you design the research, you see that sometimes you can do research with a retrospective patient data. Retrospective patient data means already patients have been treated, and all their data are available with you, with its proper annotation, etc. But for many other problems, it is not sufficient. You have to do prospective study. And there, this longitudinal plan, study plan has to be in place. So, with this background, let me present you some of the case studies. And because of the shortage of time also, I will skip some of the details while presenting these studies. That in our research group we carried out for the last 4 years. And so where I will also point out some of those issues what I mentioned, that how you have faced them and in what way if you either if we are successful in answering that part, or maybe we had some limitations because we could not access it. So the first one is the image-guided radiation therapy for colorectal cancer. So the background here is that here the cancer is in the part of colon and also rectum, and when the patients are diagnosed with cancers and it is decided that they have to be given radiation, and for designing the radiation, there is a radiation plan. So for planning the radiation, it is required to identify the volume of the tumor, required to locate the tumor, and not only that, while you give radiation to that particular volume, you need to also consider certain tolerable areas on and above that tumor, because you try to eradicate cancer as much as possible, so that ideally no cancerous cells should be there after radiation. That is the kind of objective, that is the kind of target you have. And so there are certain things like that in this diagram I have theoretically shown. Suppose this red zone is the actual tumor area, which is called gross tumor volume, and then there is a clinical tumor volume. Based on this, there is certain clinically recommended thickness of that tumor, around that tumor volume, that has to be considered for the clinicians, and that is the clinical target volume. These are called target volume, not the tumor volume. And then after that also, with that clinical target volume, once again, there has to be another level of tolerance, because when you are placing the patient in the corresponding platform of accelerators where the radiation is going to be given, it is not, as I mentioned, that it is not that it is a single-day phenomenon. It runs for weeks, say 5 weeks to 6 weeks. So every day you have to place the patient there, and there could be variations in the anatomic positions because of that placement. So physicians, they do try to take care of by putting some external markers, but still there could be anatomic variations because of the placement. Not only that, the internal organs, tumor is a part of internal organ, they also move. So there are movements for that. And also that during radiation also it's a kind of dynamic process. The cancer is a dynamic. So sometimes tumors, they get shifted also. So considering all these things, you have to consider another kind of tolerance which is statistically decided by the margin of error of decision of by the margin of error of these movements, due to these movements. And in our study, what we would like to do, the physicians, what they do, they decide about this margin by calibrating the machines or by observing the deviations over a group of population and physically measuring the positions and then physically determining their variances of their positions. And then from there, they identify this margin. So we would like to implement that. So that this could be made fast. Though this is not an everyday action. This is suppose you do it in 6 months. Over the 6 months you do it, calibration and you use it, but still it will lose the effort of the position. So we took this particular problem and so these are the background. I'm just omitting and just mentioned about this thing. So and here you see that as I was mentioning that the radiotherapy is a fractional radiotherapy, which means you divide the total amount of radiation into several fractions and give it per day with that fraction. And then variation comes, these are the different reasons I mentioned already. And there are 2 types of errors which we need to compute. One is called systematic error. And in the systematic error, it is the error due to an individual patient because of the patient's particular characteristics of anatomic, different various anatomic characteristics. And there is overall, random errors where it is overall over the group itself, there could be deviation. So we are trying to compute these 2 things, over the population and for its individual group. So there are 2 types of variances we would like to compute. One variance is for an individual patient movements variation and over the population. So these are the 2 we would like to compute. So this is the model which is used for computing the margin, which is, as you can see, is a linear combination of these 2 particular variations, systematic and random, and these are all standard deviations of those variations. So our problem formulation is this: computer-aided rotational error analysis for determining, say, planning target volume of radiation on colorectal tumor. And we have a research team. This is our research team which worked on this problem. From our side, myself and my colleagues are there, and Shai Khani was doing her master's during that time, doing his master's that time. And we collaborated with a cancer hospital in Calcutta, which is a tertiary center, Tata Medical Center. And the oncologist Dr. Indian we collaborated with us. But they provided all the data and they also performed, they have given us the ground truth data for validations. We kind of analysis together. So, kind of data that we have used in this particular case, we consider, we have used the CBCT images of the patients which has been taken during radiations. I skipped those slides. Actually, this is a machine which can be used for providing radiotherapy guided by the images. So they are follow-through. So when you give the radiation, simultaneously you can take the images during in the platform itself. And CBCT is the full name is Moonbeam CT. It's a kind of modality where you use the projections of X-rays, multiple views from multiple views, and then you reconstruct the three-dimensional views. Otherwise, normal CT, they are called fine-beam CT, where you have the cross sections. Every cross section is reconstructed using the computation scan. So the advantage of CBCT is that it is a low dose, it requires low dose radiation, and which is a requirement because you are giving it so many times to the patients, you are exposing the patients to it so many times. But the disadvantage is that it's not so clear. It has a lot of noise, and it is not used for diagnosis. So that is a problem. However, physicians use it for understanding the tumors variations, tumor strength. So in our case, we have used 20 patients, and they are, I think, 5 weeks data. So, and there are two particular anatomic positions that we consider in our methodology that we have detected. One is called cubic synthesis, another one is the topics. I can show you the. So the idea is that you have to register all the CBCT images under a common coordinate framework because we would like to measure the variation of the locations of those. We have used these two anatomic positions. With reference to that, we have to take the variations. And then we automatically we should identify these anatomic landmarks, and then we can compute the systematic anatomy. So as such, methodology wise, it is very direct, and these are certain registrations, results, etc. And there are some algorithms of locating this particular cubic synthesis and topics. So I'm not going into details. So there is a paper which has been referred here. And these are certain results related to that. And we found actually that it has good correlation with the ground truth data. With that, so this is just an example that example of a study that we carried out, and we could take some at least we have make the objective. Objective was not very difficult in this case. It was quite direct, but no, it is depending upon research plan and design. Next one was more ambitious. The next case study was about the prediction of the outcome of the radiotherapy. So in this case, it is the same setup, but here the patients are lung cancer patients, and they are given radiations over the weeks, like fractionated radiotherapy, as I mentioned. And for every day, you can take the image of the CBCT. So CBCT images of a patient is available. And our objective was, by analyzing those images, by observing the change of tumor shape, volume, etc., can we predict the outcome of the radiotherapy? Which means that for the patients also, after radiation, after 3 months, they come for a checkup. And that time, clinicians, by observing the state of the tumor or organ, they decide, they group the patients into few categories. They call there is a criteria. There is a criteria for RECIST criteria, and by which they can say they can categorize them into different stages of their prognosis. And our objective was that whether we can predict that outcome well ahead of that. So either during radiation or after radiation. So that was the objective. By observing, by analyzing the CBCT images. So these are certain backgrounds. As I was mentioning, these were lung cancer patients, and we have to usually for every patient, this is the amount of radiations we used to give 60 days. This was about 30 days, which means 6 weeks. So 5 days a week, so 2 weeks, 2 days a week. And CBCT images for patients taken before daily radiation to a therapy. And after 3 months, they follow up CT taken and radiotherapy responses are observed. So as I mentioned, there is a RECIST criteria by which patients are categorized depending upon their outcome of their treatment by the physicians. So there are groups in the complete response group, and where disappearance of all target lesions. So you see tumor is like a homogeneous mass. So it's lesion. So there are clusters of parts of cancerous groups of cancerous tissue. Those are the lesions. And if it is completely pure, nothing is observable. Pure means not visible to the image. So they take a CT image. And then none of them are observable, then it is considered that complete response. And also there are other categories like partial response, where they measure the diameter of each lesion, and it is the sum of the longest diameter of target lesions taken as reference. So this is the kind of very much precise definitions by which they categorize the patients under partial response. Then, where response is not proper, there are other categories like stable disease, progressive disease, and distant progression. So what we did in our method, we have simplified these categorizations into two groups as responsive and non-responsive. So in our data set, it's a retrospective study. We had around 60 patients data, but out of which 53 patients, final outcome was provided. So out of them, there are complete response and partial response. Those categories are considered as responsive, and stable disease and partial disease is considered non-responsive. And then what we did that we considered measuring the first is that the delineation of tumor volume is important because variation of tumor volume over the weeks, that is one kind of indication. There are prior studies, they also consider that as a factor. Then another thing they have considered that is called in the tumor zone, what is the average CT number? That's hospital units number. So that itself, earlier prior study, they use these two particular measures and using them, they try to categorize. Now, we, first is delineation of tumor. We try to automate this process, but it is difficult. I mean, our accuracy was not so good. So finally, the physicians, they have to delineate. Okay? So they have given us the delineated tumor volume, and our protocol demands delineation should be by the physicians. That's a tremendous task that you understand. And then after that, with that information, whether we are able to do it. Now, what we have contributed that on that, in addition to those particular measures, we have used another measure, which is basically we have applied a registration on the tumor volume over the weeks. So while doing registration, it's a deformable registration. So you can measure the deformation field, you can control the deformation field, and there is a differential calculus analysis. If you get the determinant of the Jacobian, that is the first derivatives are in every direction. You get it in the form of a matrix. That's the tensor element. And if you get the determinant of that matrix, now if the value is greater than 1, which means it is expansion. If the value is less than 1, which is shrinking. So this is a kind of physical interpretation of Jacobian, and we used it in this case. So we have identified, after registration, we have identified zones of where the reduction of tumor is there, where the growth of tumor is there, and we set some methods. So let me quickly go through these are other measures. So, just to complete the thing, so this is a research team on which we work on this problem. In fact, this problem we are still working on. So I will just present the part unfortunately because I said the data set it was very limited number. So we are trying to do the prospective study and consider series. So our objective is early prediction, as I mentioned, and some of the things. So the data you can see, as I mentioned, there will be 53 patients data. So this is the principle. After registration, you can see that the tumor. This is suppose this is a previous week's tumor, and then this is the dashed line is the subsequent week's tumor. And then we have considered the different zones over this. Like this is the zone of reduction. This is the zone of which is already shown. So one of the part is reduction zone, then the other part is newly grown zone and unchanged. And here, statistically, we have compared the Jacobian span between these two. And then we formulated a hypothesis. It's a kind of deductive way after observing, and then we perform the statistical test. So this is the definition of it. So we found this hypothesis to find out the average value of Jacobians in different groups with the statistical significance. So all these comparisons are with statistical significance. And with this hypothesis, we are declaring this responsive and non-responsive. Our result was not good, though it has improved the state of the art. It is not like so with this additional hypothesis, it will improve our result. But as the number of patients is also very less, not, no. We need to do the study now. So I will be skipping this part, and I will go to the next case study, where I will give an example of neurological examination results. How much time do you have? So in this case, it's an example where actually you can use simple image processing and video processing. That means simply use the already instrumentation, but still you can do meaningful research in the healthcare and take the clinicians in the diagnosis. So the background here is that in the neonatal intensive care unit, the neonatal baby there are 28 days. Babies within 20 after the birth within 28 days they are called neonatal. So when they come with different complications, they are put into an intensive care unit. And but after their treatment, when they're released, still they needed to follow that. And because to observe monitor their growth and to observe their growth. And there are different neurological examinations which physicians they need to carry out on the babies, and that is still even infants, till say 9 years, till the 9 years old. It's a longitudinal study. Now there are some standard chart, standard neurological examination tests. So one of these tests, I will give you an example. This is from the Hammersmith Institute of Neurological Examination. And there, in the chart, you can see that this is one example. The baby would be pulled towards the person who is carrying out this examination, and the way the baby carries his or her head with the body, from there the physician has to categorize the baby's growth into different groups. So the corresponding you can see from left to right there are different positions of the baby's head, and if the baby's head lags, then the growth is abnormal. Growth is not normal. If the baby carries, the growth is. So what we did, we translated this problem as a tracking problem of head and posture. And there is an example here. I'm not sure whether the video is on. are not going to be played here in the system. Anyway, you see that from the diagram, the circle and the line has been drawn in the first frame by the physician, and the rest of the things tracking is done automatically by a constellation. And by observing the corresponding positions, we simply measure the angle between these two. And then if the angle is obtuse, as you can see that rather the angle is more than 180 degrees, then we can consider it. So it was a simple factorization, but it was effective. So just to, before conclusion, I will give you, since I've got time, I will give you an example of the other kind of study that we carried out related to medical informatics, where we are not dealing with images. So here in this study, what we consider it is the lymphoblastic leukemia. So taking interesting cancer hospitals in work with them. So there are different treatment regimes for these children, and one of the last stage of this regime is the maintenance therapy. So once the children are diagnosed, they are treated, and then they have to go through about 96 weeks maintenance therapy. And in this maintenance therapy, what the clinicians do, they prescribe 2 drugs, particularly to maintain their neutrophil level and also the blood count, the platelet counts. So they should be in the desirable zone. So it's a kind of feedback, and it's a kind of very much it's a kind of control, problem of the control. So they have to be in the desirable zone. So if they are below the desirable zone, then they stop the drug. If they are above the desirable zone, then we administer the drug. Now there is a protocol which the clinicians they follow. But the problem here we found, the doctors told, some of this maintenance therapy is not properly working. So they wanted to know where is the problem. There could be 2 types of problems. One kind of problem would be the drug adherence problem from the patient side. The other problem would be the drug administration problem from the physician, because they do not follow the protocol as per the guidelines. And it's a bit complicated. The protocol is not so simple. What I summarize in sentences, but it is not so simple. There are some other parameters also we have to consider. So what we did in this study, we have considered, it's a retrospective study. So we have considered all the prescriptions of the physicians and also the corresponding patients' outcome also we know. And then we found out that how much of that prescriptions are following the standard. And there we found there is a large deviation. At least 40% of cases are not following. It's a kind of eye-opener to them. And then again they changed their, they have sensitized the doctors and they make some protocol to make it. And it is also a continuing study that we have. So let me stop here and just summarize my talk by going to the last slide. So just to conclude about doing research in this area, as you can see from this case study, that formation of research team is very important, and particularly it's an interdisciplinary research as I highlighted, and then the close collaboration and interaction with medical doctors. Then formulation of a research problem where if you are really interested in doing research in this area, it is better to avoid template research. Template research in the sense that of course there are interesting data available and you can choose some problem and you can do the research. But still you should have collaboration with doctors. And try to do some living research, address some local problem, because healthcare is a very complex phenomenon and it's very much complex. So the data generated by some other countries may not be very much relevant to your context. And you can always contribute generating new data from other countries. So you should think about that kind of research which is motivated by those things. It's a real life problem. And it is more uncertain than it is more exciting. Also, feasibility should be checked. Follow the systematic study and analysis where you have to check the fundamentals and statistical inference is one of the he checks. That we should consider. Never come to any conclusion without doing that. I think with that, Mr. Sophia, thank you for your questions and thank you.
In the first case study,
Uh,
consider 20 patients.
Yeah.
What is the condition of the present level?
No, there's stage 2, I suppose. There are certain protocol. I think there is stage 2. Because they are going for the radiation, so there are certain conditions for that they are doing.
Second question, in case for the during the for the PET scan, go for the PET scan,
No, so these are not already tested. So definitely those tests have been carried out and then only they are determined. I don't think so. I mean, so only the clinicians can tell you reliably if there is any side effect, etc. So in hard way saying no is very difficult. But as a layman, only I can say that no, these are trusted protocols. So they follow them. Pardon? No, it is also test. Yeah. How to deal with? We were saying the multiple modalities, multimodal. View means no, sometimes if you have three-dimensional images, there are also different views. But no, as I understand, your question is multimodal imaging. Like you have PET and CT both. Like that, you are saying? On the same organ. Right. So usually, there are certain in-person tasks you have to do for that. For example, registration is one of the criteria. Then putting them under the same coordinate framework. Then the fusion of information, and it's, as I mentioned, it is also empirical. So now, whether that fusion is improving the diagnosis, that no, in the context of this. Okay, thank you very much.
Thank you so much, sir. Please give a loud round of applause to Professor Jenkins. Thank you so much, sir. I kindly request Dr. Joseph Paul to give away a memento to Professor Jayanta as a token of our respect. Thank you so much, sir. We will be breaking for 10 minutes, and after that, we will start with the best paper sessions. This room, that is Gallery Hall number 23, will be hosting the CoCoNet' S08. And the chairs will be Shirley ma'am and Kalaivari Anvarasan ma'am. So they both will be here, and they'll be having a session at exactly 2:50. So if you have your presentations in PPT, please bring it to the front right here in the next 10 minutes. Thank you.
അതുപോലത്തെ വാങ്ങിച്ചിട്ടുണ്ടെങ്കിൽ
വയർമാന്മാരുടെ ഒരു
ഇപ്പോഴും ലൈവ് നടന്നുകൊണ്ടിരിക്കുകയാണ്. ക്യാമറ ഓഫ് ചെയ്യാറുണ്ട്.
ഓഫ് വെച്ചാൽ നമ്മൾ ബാഗ് അഡാപ്റ്റർ ചെയ്യുന്ന കുഴപ്പമില്ലെന്നോ അയ്യെന്നോട് ചോദിക്കത്തു ഓഫ് ചെയ്യണ്ട അങ്ങനെ അടകട്ടു അവിടെ ക്ലോസ് ആക്കി വെച്ചിരുന്നാൽ മതി. എനിക്ക് കാണുന്നവരൊക്കെ നിർത്തിയിട്ട് പോകും തീർന്നു പറഞ്ഞു. ഇല്ല അത് ഓഫായില്ല, ക്ലോസ് ആയില്ല. അത് കിടക്കട്ടെ.
May I have your attention, please? Is every paper presenter here today, right now? Except for the fifth one. Just read out your names. Is there someone named Mekadoti Vamsi Kiran from National Institute of Technology, Kochi, NIT Kochi? I gave you guys numbers. So there's 1 here, 1, 2, 3, 4, 5, oh, 5 is not good, 6, 7, 8.
So, good afternoon, one and all. Welcome to the session on Best Paper as part of 3rd International Conference on Computing and Network Communication, CoCoNet'19, and International Conference on Aspects of Computing and Communication Network, ACN 19. This session is chaired by Dr. Elizabeth Shirley, Professor IIITM-K and Kalivani Antarishan, Sarvika Institute of Medical and Technical Sciences, and Savita School of Engineering and thank you. Then this session consists 8 papers and allotted time for each paper is 15 minutes and 5 minutes for discussions. Once again, I welcome you all to the session and hand forwarding the session control to the chairs. Thank you.
Representative number 1, please come. Yes.
The first presentation, Voice over IP HTK2, a novel channel allocation technique for QoS aware voice over IP communication over heterogeneous networks.
So, good afternoon everyone. My name is Atul Kumar. I am from BITS Pilani and I am the surrogate presenter of this paper because the authors could not make it as they are having semester exams right now. So, what I'll be doing is I'll be taking you through the presentation and all the questions they must be posted to they can be posted to the authors via email. So, this is their topic, a novel allocation technique for QoS aware voice over IP communication over heterogeneous networks. And the authors are Tamal Chakravarti, Subhadeep Ghosh, Sayanta Barik, Sampriya Kar, Subhadeep Chatterjee. This is the basic outline of the presentation. They've started with the problem statement, then motivation of the project, then the methodology they have used, and the component was discussion of the project, and they've ended with the conclusion and future scope. After that, they have given the references. So this is the problem statement they have given. So basically, I don't have any idea about these concepts. I'm a microelectronics guy. So you'll have to help yourself. What's the name? And they could not come, so they texted, they contacted my mentor from my college, and my mentor told me that if you can, then you just present the slides. That is all you can do. Okay. This is the problem statement, and the current solutions they have given as these three current solutions. The motivation is analytically driven estimations. This is the proposed methodology. No, ma'am, I am from BITS Pilani. Those people, one of the authors is from Jadavpur University, Kolkata, and rest of them are from Future Institute. I don't know how they got email ID of my mentor. I don't know how they do it. Thank you, everyone. Ma'am, I have a paper to present.
Thank you, sir. So we are moving to the second presentation. Creating a dynamic real-time green corridor and assessing its impact on normal traffic flow.
afternoon to everyone. I'm Dennis Yadav. I'm presenting on behalf of CoCoNet'19, creating a dynamic, real-time green corridor and assessing its impact on normal traffic flow. There are some outlines of motivation, background information, proposed method, and results from future work and preferences. Motivation scenarios and lifestyle demand, urban mobility, poor traffic sense, and distribution prices of service, traffic congestion control is a real life problem. The motivation effect are of first congestion on the road, emergency vehicle getting a stuck, creating have road accident, life risk, death due to reaching a critical spot of hospitality, point of incident. Next report we are engaging medical report to provide the differences of the more than 50 of heart attack cases are due to arrival to the hospital on the time. Existing approach, manually creating a dedicated green corridor or emergency vehicle, but is not very viable solution of required to lot of human involvement of successful implementation of existing approaches. So I have proposed one hope and two hope approaches. Proposed method, propose a novel technique of finding the best optimal path and creating green corridor for clearance of emergency vehicles using IoT technology. First of all, a dedicated green corridor and second a dynamic green corridor. Their proposed methodology. First, vehicle of agent who finder who traffic data on traffic processing step and traffic processing method data refers to the data acquisition center to receive the data of through RFID camera and GPS. Then to reply the route optimization and select the optimization of route to response agent to the vehicle and vehicle then create the green corridor and vehicle set to go for normal route and create green corridor. The key component of proposed method, RFID tag fitted in emergency vehicle, RFID reader installed at each traffic post, a central traffic management server is deployed at traffic control room, a GSM module at each traffic process for communication traffic server to central transport management server. Messaging is sent to the GSM property. The finding the best optimal path to determine the best optimal route. Condition factor that is based on the distance with the path and average of speed traffic flow is calculated as CF and this factor to calculate the best corner path to send the vehicle of emergency hospitality and other vehicles like fire brigade, police. Approach 1, dedicated corridor. First of all, vehicle send the response to the central traffic server, management server, and traffic central traffic management server to respond to the vehicle emergency and will create a single home corridor and a dedicated corridor to send the vehicle to destination. The approach of dedicated corridor. Second approach is dynamic green corridor. This dynamic green corridor is selected on two hubs because one hub is less than 20 meter, 30 meter. So first of vehicle is sent to next hub vehicle is coming to 2-3 minutes to have created two hubs. long distance estimate of the vehicle condition, reduce the condition of the vehicles. Then approach offered to dedicated green corridor. Simulation scenario. Time taken for any vehicle to reach from source to destination during normal traffic flow and congestion. Our time taken for a EV to reach to destination. Then a green corridor is created and effect of this normal traffic flow, creating a dynamic real-time one hope green corridor and again its impact on general traffic movement, creating a dynamic real-time two hope green corridor and again its impact on general traffic movement. Simulation of urban mobility. It allows the model to intermodal traffic system, include road vehicle, public transport. Road network can be generated either randomly or importing a digital road map. Yes, simulation result analysis to Google Map. The simulation result. First we had low condition and high condition traffic, start time, end time, and unit times to unit. Start time of number of units in simulation 33 and end of 365 time unit is 332. And next is high condition. Next table is the comparison of normal route and high traffic green corridor. We have improved the result of pure green corridor. The second simulation result. Graphical analysis in normal flow and dedicated green corridor, one hop green corridor and second hop green corridor. The dedicated green corridor to best result provide, but there are some stop all the traffic on the road. But second hop green corridor is only two station stop the traffic, and other station are normally move the traffic. It will increase the efficiency of the normal flow of green corridors. In conclusion, the proposed approach utilizes various crucial parameters such as congested and density, average speed of traffic flow, distance, and width of the road. Experiment result reveals that the travel time of vehicle reduced up to 33%. If it follow optimized route obtained from the proposed approach. The green corridor allows the emergency vehicle travel from source to destination without any traffic condition. The average reduction of travel time for 5 different simulations of an emergency vehicle from source to destination is 56.6%. The future work can consider the proposed approaches will work to be used for the real-time traffic is live saving, clearance, advanced situation on traffic like on uncertain breakdown of vehicle over the route selection in case of road accident. The differences. Yeah. In this approach, we have covered two traffic, signals for the traffic and other good is normal, vehicle is good normal. Then vehicle is going RFID or all RFID included in vehicles and station. So send the message to have coming the vehicle and this two condition to block road vehicle. Traffic is blocked and other is working on it. And next is cross and next is further next to send the vehicle information and other station is road vehicle traffic is blocked and other is on back side is open and next to next open. And next to send the message and control the green border is all traffic blockage. But two hot green border is only two stoppage are like vehicles are stopped, traffic is stopped, and other vehicle is normally cleared. These are the pros of green border right to move this green borders. I'm not implementing this paper on the behalf of no, I'm also sorry. Maximum 1 lakh vehicle are created currently. No, only one vehicle. Other vehicle are coming next week. One vehicle are coming just second. First response next week, hot to hot. I'm not implementing this. Thank you.
Moving to the third paper, an upper bound for sorting permutations with a transposition tree.
Good afternoon, one and all. I am Sai Sarkar from Amritsar University. Today I am going to present my paper, an upper one for sorting permutation with a transposition. Presentation will proceed in this manner. First, I will go through the introduction, the problem definition, the prior work, the terminology used, and the algorithm, and the analysis of algorithm on different types of trees, and followed by the references. A processor interconnected network is often an undirected graph where the vertices of the graph correspond to the processors or communication ports, and the edges of the graph correspond to the communication channels. And for such type of networks, the communication is achieved by some message passing protocols, and delay in the communication is measured in terms of number of edges traveled. And in the morning section, as the professor Ras said, the performance of a network can be measured in terms of various factors. We have various factors to measure the performance. One is degree, diameter, symmetry, connectivity, routing algorithms, and it depends even on the structure of the graph. So we have variety of interconnected network topologies, and from very simple graphs like cycles, complete graph stars to the complex graphs like shuffle extents graphs, enables and Boolean cubes and the cube connector cycle. Since there is no particular measure to evaluate to compare this type of networks, these networks have their own advantages in their respective fields. And one class of interconnected network is the symmetric interconnected network, And the property of symmetric interconnected network is the graph looks similar from any vertex. So the graph is symmetric from any vertex. So because of this property, the entire load of the network can be distributed equally among all the vertices. And moreover, this property will bring an advantage that we can apply similar processes at every vertex, and we can apply similar routing algorithms. And Eckerson Krishnamurti, these two guys developed the group theoretical model called K-graph model, and it is used for the designing, analysis, and supervising such type of networks. And it was shown that the K-graphs can model any symmetric interconnected networks, and the extension of K-graph by the extension of K-graphs are K-graphs. And because here the network is modeled in a graph, the diameter of the K-graph is equivalent to determining the maximum possible latency. Latency here is the maximum number of edges traveled, or what is the maximum distance traveled, right? So the diameter of the K-graph will have a significant effect on the latency of the communication. And it is proven that the diameter of the K-graph is an intractable problem, that is an anti-hat problem. And but diameter, upper bound of a diameter can be found, and there are many algorithms, exponential time complexity algorithms, Born-Hammond time complexity algorithms. And this is a type of K-graph. Every K-graph will be defined on a finite set, and here I am taking the finite set as all possible permutations, and there will be a set of generators. So the vertices of the K-graph will be the elements of the finite set, and the edges of the K-graph correspond to the axes of the generator. If you take any two vertices A and B, there can be an edge between A and B if there is a generator G such that the action of generator G on A will be stretched to B. So this is an example of the simple K-graph. If we consider any vertex, for example 2, 4, 1, 3. 2, 4, 1, 3 has 3 adjacent vertices. These 3 adjacent vertices are obtained by the action of these 3 generators 1, 3, 2, 4, 2, 1, 4, 3 and 4, 3, 2, 1 on 2, 4, 1, 3. The generator 1, 3, 2, 4 literally means that the second and third position of the permutation can be swapped. So the application of 1, 3, 2, 4 and 2, 1, 4, 3 will be the second and third position will get swapped. That is 2, 2, 1, 4, 3. So there will be an edge between 2, 4, 1, 3 and 2, 1, 4, 3. In such a manner, the graph will be constructed. And this graph will be modeled as the symmetric interconnected. And we are sorting the permutations with the transposition trees. Transposition trees are nothing but spanning trees. We know that spanning trees will have n vertices and n-1 edges. And here the vertices are the positions of the permutation. We have permutation, right? In a permutation there will be position, and those positions are considered as the vertices for the transposition tree. And NK transposition tree is considered as one operator, and the edge between I and J implies that the element at position I and position J of the permutation phi can be interchanged or can be transposition or swapped. So because this spanning tree will applicable for transpositions, it is called as a transposition tree. And in spanning tree, we can have a path between any two vertices. So if we apply the same procedure, here we can swap any two elements in a transposition tree. Hence, this transposition tree will generate the entire symmetric group SC. And this is an example of the transposition tree of 5 vertices. There are 4 edges, and each 4 edges correspond to generators. There are 4 generators mentioned over here. And the main advantage of this transposition tree is here we will analyze the tree of n vertices. But the graph constructed from this tree is of n factorial vertices because we will have n factorial permutation. So the K-graph constructed from this is n factorial. So we can analyze the properties of the K-graph, large K-graph of n factorial vertices by just analyzing the properties of the transposition tree of just n vertices. And here the main objective of this paper is to sorting a permutation with a transposition tree, and it was shown that the upper bound for sorting a permutation with a operation is estimated as the diameter of the K-graph. It was shown by the Eckerson Krishnamurti, and the exact upper bound will be equal to the diameter. And this is also an intractable problem, that is an anti-hat problem, but computation of tighter upper bounds is of both theoretical and practical interest. We can compute the tighter upper bounds, but we can't compute the exact upper bound for a transposition because it is an anti-hat. And it has applications in genetics and the interconnected networks. In genomic studies, a permutation is modeled as a genome, and in the computer interconnected network, it is modeled as a node. And the prior one, with respect to this paper is Akers and Krishnamurthy, they computed an upper bound. This is non-trivial upper bound, and the time complexity is of omega of n factorial into n square time. Later, Ganeshan gave an upper bound beta max in exponential time, and Kraft gave an upper bound of alpha, beta, and beta in exponential time. And the Chittur, he is one of the co-author of this paper, and he has designed a linear time algorithm. This linear time algorithm S will identify all set of vertices in the graph which are having the maximum eccentricity. And he also designed an algorithm delta dash which computes an upper bound delta dash. And recently he has given another algorithm delta star which computes an upper bound of delta star. And in this paper we are combining these two algorithms, algorithm delta dash and delta star, and we are experimenting our different class of trees by this algorithm. And the technologies used in this paper is one is depth is the depth of the tree, and eccentricity is defined for every vertex in the tree, and the maximum distance from node B to any other node is the eccentricity of the tree, and diameter is among all the eccentricities of all the vertices, the maximum eccentricity is the diameter of the tree, and we are defining set S as tree with maximum eccentricity, and the cluster is a subset of S where the any two vertices in the cluster will are less than diameter distance apart. And this problem can be modeled as a puzzle. Here there will be a transposition tree, and there will be a set of markers 1 to n, and the set of markers are positioned at the vertices of the transposition tree in an arbitrary order. And the home of a vertex is like if phi of I is equal to k, then k is the home of the phi of I, and the homing is the execution of some sequence of nodes along the edges of the transposition tree, such that the phi of I move the phi of I to its home. And by solving this puzzle, we can get the solution for the sorting any permutation in SL. And this is the clustering algorithm. It was given by Chittur, and this algorithm finds the all the clusters of a tree in linear time complexity. And in this paper, we have designed this algorithm delta dash star. This is an like combination of delta dash and delta star algorithms. And before going through these algorithms, I will explain what this algorithm does. This algorithm finds an upper bound for sorting permutation, and it deletes the leaves. And the cost accounted for deleting a set of leaves is considered, and we will delete leaves. And this process is iterated till we get a star graph. And for a star graph, the exact upper bound is shown. And diameter of the tree here denotes the maximum distance a marker must move in order to get home. This is which I explained in the previous slide. This is similar to puzzle solve. And the markers that are homed to the leaves need not be. So once any marker is homed to the leaves, they need not be moved again. So those markers can get deleted. So in such a manner, we will keep on deleting some set of leaves in each iteration, and at the end, we will end up in a star graph for which the exact upper bound is known. And this algorithm first computes C star is the largest cluster from the S, and according to the definition of the cluster, the maximum distance between any two vertices is less than the diameter. And if for suppose there are k clusters, so if you delete k minus 1 clusters, then we can be sure that the diameter of the tree will reduce by 1, because in a single cluster, any two vertices will have a distance less than that of the diameter. So in such a way, the diameter of the tree will get reduced. And the proof of correctness of this algorithm was given. As mentioned, the algorithm is divided into 3 cases: case 1, case 2, and case 3. And BC is the set of vertices in S which are not in C star, that is S minus C star. And case 1, the cases are divided based upon the cardinality of the BC. If the cardinality of BC is greater than or equal to 2 by 3 mod S, and the cardinality of BC is greater than or equal to mod S by 2, and cardinality of BC is less than mod S by 2. These mod S by 2, 2 by 3 mod S is not taken arbitrarily. There is a mathematical proof given in the paper for considering these cases. So in this manner, we will account all the cost required to delete all set of nodes. So this the required cost is accounted, and this measure is a valid upper bound. And now we will compare the values of delta star, which is defined previously, and delta dash star on various set of trees. First, we will compare on full binary trees. In full binary trees, there will be three clusters: C1, C2, and C3. C1 is the cluster on the left subtree, C2 is the cluster on right subtree, and C3 is the cluster connected by the subtree by the upward edge. So it is observed that this delta dash star value is different from the delta star only when cardinalities of all the clusters are same. So delta dash star eliminates when delta dash star is applied in one iteration, it will eliminate entire as the cost, and the cost accounted is 3k by 2 into 2 into diameter of t minus 1. And if you apply delta star algorithm also, it will take 3 iterations, but the final cost accounted will be the same, that is 3k by 2 into 2 into diameter of t minus 1. So what we have observed is proven is the values of the delta dash and delta star will be the same for all for full binary trees for various number of nodes. And this is an example. Here there are two cases. If you consider this is an intermediate stage, and here we have three clusters: cluster 1, cluster 2, and cluster 1, cluster 2, and cluster 3. We can delete either cluster 1 and cluster 3 or cluster 2 and cluster 3. So we will get two possible cases, but these two cases will end up in the same result. And if you see the cumulative values of delta star and delta dash, these values are same for all the nodes. 1153 and 2807 and now we have compared the values of delta star and delta dash star on extended binary trees. In extended binary trees, an extra A nodes are added to the binary to full binary tree in such a manner that these A nodes are positioned in such a way that the payable distance between the nodes get maximized. And here the entire scenario we divided into the three cases: when A is less than 2 per t minus 1, when A is equal to 2 per t minus 1 and 2 per t, and when A is greater than 2 per t. And in all these cases, we have computed the cost required to solve the permutation. And here in this case also, in extended binary trees also, the cost required to solve permutation with delta star and delta dash star algorithm ended up in the same value. When A is less than 2 per t minus 1, the cost is load of A by 2 into diameter of t plus sin of A by 2 into diameter of t minus 1 plus answer of D. Answer of D is the cost required to solve binary tree, full binary tree. And this is the same case with the costs are same with respect to case 2 also, when A is 2 per t minus 1 or A is equal to 2 per t, and with respect to case 3 also. And this is an example how the clusters got deleted by applying delta dash star algorithm. Initially, in the first iteration, the cluster C2 got deleted. And these are the experimental values for various values of A. And another class of trees is a starburst. In starburst, we have this is another class of tree. There will be a P stars, P stars, and all the centers of these P stars are connected to a single node. And for starburst, in a starburst, the total number of nodes is k plus p plus 1. And here also the values of the cost accounted by delta star and delta dash star came up to same value, that is 3.5k plus 1.5p and k is even, and 3.5k plus 1.5p minus 0.5 and k is odd. And there is another class of tree which is a subclass of starburst tree, that is SPM flat. And for this values also, for this class of trees also, delta dash and delta star dash are identical. The clusters deleted are identical, but cost accumulated is different in each iteration. Delta dash star cost in each iteration is lesser than that of the delta dash. So we can say that for moderate flat starburst, the cost accumulated by delta dash star is tighter than delta dash. And this also solves a famous mathematical problem, Williamson-Forsyth problem. We have to find the number of solutions for x1 plus x2 plus 1, xk is equal to n, and constraints are x1 xj is less than or equal to xj plus 1 for all values of j, and this constraints are similar to that of the constraints of morphic flat starburst, and hence the delta dash star algorithm is applicable for this, which gives a very tighter upper bound. And conclusion is, in this paper we have given a novel upper bound of diameter for the diameter of the tree, that is using delta dash star algorithm, and it is lower bound than existing diameter. And for full binary trees, extended binary trees in SP flat, the measure of delta dash star is identical to delta dash, and for the SB subclass of SP flat, that is SB modified flat, the delta dash star is tighter than delta dash. And these are the references considered in this paper, and that's it. Like the conclusions I have mentioned over, the proposed algorithm, we have given a novel upper bound delta dash star for sorting permutation with transposition trees, and it is given tighter upper bound than the existing node. As delta dash star is tighter than delta dash for a class of tree, and this class of tree can be modified as a tailor class, which have applications in genomics and and it is also solving the problem of Paris discrete math problem. We use the problem is here.
Thank you. Moving to the next presentation, graph similarity based hierarchical clustering of trajectory data.
Good afternoon. I am Sabaresh. I am presenting my paper on graph similarity-based hierarchical clustering of trajectory data. I just give a brief introduction about what is the trajectory data and move on to what are the applications related to that.
The trajectory is nothing but you are moving objects of the GPS data is loaded. So mainly it has gained in importance due to the location-based services to provide a quality of service. So the location-based services data are collected based on your GPS devices and it is tracked. It is going to be a huge amount of data. It's going to be a big data topic. So it has got various type of data. It can be a spatial or time-based or semantic or uncertainty based on your location. When you're moving on a path, the path is not going to be a fixed one. It is going to be a maximum of uncertainty is going to be there. So it imposes three open challenges that is not directly comparable with the individual routes based on the GPS values. So it has to be the calculation of segments will be bit tougher, and it is going to be the establishment of topological relationships. So it has opened up three representation areas that is going to be the trajectory data analysis. It is going to be on feature representation or similarity, or it is going to be based on how they are going to be clustered. These are the three major challenges we are facing in this. So based on this, we are taking on to the application. It can be on your intelligent traffic analysis or facility recommendation algorithms or hotspot locations or AR infrastructure-based development based on the location-based services. So based on that, we have gone through all the 5 already available trajectory clustering and motivation technologies. So first one is the famously introduced one. First one is the trackless algorithm, which does they're using the minimum description length, the MDL principle. It just converts the number of points into the, if your trajectory is having n points, it just reduces them into the log n points and just tries to compare it using your line segments. It just makes the trajectory into the sequence of line and just compares it. The next one is going to be the partition, cluster, and extract. It just divides the clusters and trajectories into various line segments or using the curve fitting algorithm. You just try to compare the subgraphs and tries to cluster them. The next one is based on the spatial segment frequency and the inverse trajectory frequency. It also the extension work of your partition and cluster. So you just try to identify what is going to be the segments impact on an individual trajectory or across the trajectory data set. So if you are having a trajectory, multiple n number of trajectories are going to be there. The spatial segment frequency just try to identify how many times the sub-segment trajectory has been occurring in a trajectory. If it is going to have a U-turn or something, in that case only you'll be having your spatial segment frequency will be more than 1. But in the case of your inverse trajectory frequency, it is going to consider the complete region and all the trajectories available in the particular region and tries to calculate the impact of the particular trajectory. The next one is the trajectory clustering algorithm. It just uses the dynamic time bombing algorithm based on the GPS points. It just the data is the trajectory is converted using into an equal strength, equal length trajectory using a Douglas-Becker algorithm. We have chosen the Douglas-Becker algorithm because it is a source and destination fixed algorithm. So we can just take the number of points to be needed so that the varying length trajectories can be pre-crossed and brought into a single equal length trajectories. The next one is the spring-based clustering algorithm. It is just nothing but your spatial grid will be formed from your geographical coordinates, and the nearest points will be forming into the spatial grids. So I will be giving the representation of that. So based on this, we have formulated this method based on just how to convert the trajectory into a graph, and just comparing the basic measures of similarity based on the edge-based or vertex-based similarity, and just applying a hierarchical clustering algorithm and just validating it. So we are choosing the hierarchical clustering algorithm because just knowing the number of clusters in advance is going to be tough without knowing the applications. So if you are creating a hierarchical clustering algorithm, here we are choosing the agglomerative clustering. Each individual trajectory as an individual cluster and mapping it together. So based on the number of k values, based on that we can just cut the hierarchical clustering tree based on our requirement as based on your applications. So there is a framework identified. As I specified, the first the trajectory will be converted into an equal length trajectory using your Douglas-Becker algorithm. So we have taken the sampling size as 10. So every trajectory will be converted into 10 points, and that will be projected into a spatial grid, which will be converted. So we are moving to the spatial grid because if you are choosing the GPS points as such, even a minor variation in the 6th decimal may cause the fixing it into multiple trajectories, grouping them into different clusters. To avoid that, we are moving towards your string-based representation, and we have made an analysis in the previous work. Based on that, what are the string distance measures we can apply it, and what is the accuracy can be achieved over that. From that, we have generated a graph based on that. But this graph also can be combined in the future work by creating a here. We have taken each trajectory represented as a individual graph, and using an
Two similarity measures, as I have already specified in the previous slide, that is edge-based as well as vertex-based similarity. We are just creating the similarity matrix and creating the dendrogram and validating the cluster measures using three measures, that is namely cooperative correlation index, the Davis-Borden index, and Dunn index. I will be going through in the next slides. The next one is how the trajectory transformation is done, that is specified. So the trajectories will be sampled first, that is going to be represented in your blue trajectory, blue line, which is going to have the almost 70 points will be there in the particular GPS trajectory, which will be converted into a sample trajectory with 10 points, and which will be mapped into a spatial grid. So based on the number of points of the serial numbers, the string will be again converted into a string representation. You can see this. The trajectory can be represented as the sequence cell numbers of 16, 2, 7, 7, 10, 13, 20, and 19. The previous literature we have just compared using the string distance measures with the comparative trajectories. Here we have just used the two similarity measures based on edge-based as well as the vertex-based similarity measure. Edge-based is just a simple interaction of edges, common edges available in the both graphs has been calculated here as a similarity between the graphs. And for the vertex, we have taken the edit distance based measure. Just it's going to be a union of strings. The number of vertices needed to represent both the trajectories in a combined manner. For the validation of trajectories, we have chosen three validation indexes: cooperative correlation index, Davis-Borden index, and Dunn index. The cooperative correlation index tries to identify the correlation between two trajectories, how well they are correlated within each other. It should be higher enough. The Davis-Borden index is the value the intra-cluster as well as the measure of intra-cluster distances and inter-cluster distance ratio. It should be a minimal one, and the Dunn index should be the maximum value. For our analysis, we have taken the three data sets. Two are the universal data sets. One is from your UCA data set, GPS Q Drive, and the next one is the Q Drive data set of Microsoft Q Drive project. To take the taxi data set to validate our project in a successful way, because these two are the international data sets. We have generated our own data set, that is TN291, across all the Tamil Nadu state. Around 300 data sets has been 300 trajectories has been generated from various 9 districts to check whether they are clustering properly based on the measures. So from the analysis we have just for this, we have calculated the measures. We have calculated all the 6 linkage methodologies like your centroid method as well as complete single and average and mod median method for both the edge-based and vertex-based similarity measures. In our cases, vertex-based methodology provides a better similarity, but even though the actual presentation like your DTW gives an accurate value, better correlation value in the case of 0.94, and whereas the vertex-based gives just 0.89, it's because it's an actual representation. Here we are just approximating it to a graph-based string, then we are approximating it to a graph-based representation. So the next one is based on analysis to choose the number of clusters which we want to create and their independent values, whether it can be n. What is the number of clusters we can generate? What is going to be the value? Here the singleton clusters cannot be found on an edge-based detection because it is going to be a null value, because the standard deviation will be 0 in the case of your edge-based similarity if you are taking in entirely two different trajectories from various data sets. So mainly in the single linkage methodology cannot be applied in the edge-based similarity measures. So this is for your DNA comparison, and just we have plotted in using how the clusters has been formed. This is how we have taken 4. It has been divided into 3. We have taken the highest cluster 4, and we have divided them into 4 trajectory clusters, and we have just checked with actually it is representing the 4 different districts which has been generated from our for validation. So we have done the same representation for other algorithm, other data sets also, but we are not able to exactly validate it because it is going to be the international data set. We are not able to predict whether they have been exactly correct or not. So we have taken this is the T-Drive data set. This is the maximum data set we have chosen for a taxi data set of Beijing city for a week. It consists of 2,500 data samples we have taken. But it's a trajectory taxi data set. Almost the taxi driver tries to cover almost all the locations. So finding an intersection is maximum. So we are not able to exactly predict it. But in the case of they are highly separated, which can be easily done. So we have chosen the graph-based representation only for the performance and visualization purpose. When it is going to be a GPS-based representation, it is tough to represent. When it is represented as a graph, it can be extended using your community detection algorithms or graph collection or domination set theory of your graph collections. Graph theory applications can be applied across various applications. In the future enhancement we have provided, here we have taken each individual project as an individual graph, so the number of size is more, and when you are going to store it, the storage complexity also is going to be high because of it's going to be a sequential representation. It will be a sparse matrix, so it can be pre-processed and created a combined region, and it can be applied for your community detection and which can be used for your infrastructure development applications. Thank you. These are the references. Here I have just analyzed which will be the best value based on the DB and rendering value. Here I have just used on the value for maximum, it's competing there. It's exactly it's a taxi data set for a complete field. So in a field, almost within a city, you can inspect for almost all the locations. So the impact is low. They are not able to locate like that. So that's what in the future mode, we are just planning to combine it into a single work and we are here let's just use the hierarchy to and use the communication mode. Yeah, based on the
Tidak. Bon. Cara mati ini.
Thank you.
Thank you. Moving to number 4, an unsupervised hierarchical rule-based model for aspect term extraction augmented with pruning strategies.
Good afternoon all. I'm from Amrita School of Engineering, Bangalore. And I'm here to present, I'm Manju Venugopal and I'm here to present the work, an unsupervised hierarchical rule-based model for aspect term extraction augmented with pruning strategy. Before I explain about the problem statement, so these are the key points through which I would go through. And before I explain what the problem statement is all about, let me give an insight into the domain, which is all about aspect level sentiment analysis. As we all know, sentiment analysis is all about designing automated system for extracting sentiment from data. Okay, and a lot of research has been happening in this area since a long time, where we were focused only about extracting the aggregate positive or negative sentiment from data. But then, as per the consumer demand or the demand, it went into a fine-grained level where we are no longer satisfied with an aggregate sentiment of positive or negative or neutral. Rather, we want to find out when people write reviews about a product or so, what are the features about which they are criticizing and what sentiment are they expressing about each aspect or feature. So that paved the way for a fine-grained subdomain in sentiment analysis, which is referred to as aspect level sentiment analysis. We can visualize two different tasks in aspect level sentiment analysis, which is aspect term extraction and sentiment classification. So the first task is aspect term abstraction, where you need to identify what are the properties or the features of the product that the reviewer is trying to criticize or talk good about. So that automation subtask is what you call as aspect term extraction, and then finally concluding whether he's saying good or bad about each and every aspect is what you call sentiment classification. So the tougher task is aspect term extraction, and that is the focus of our proposed work. Again, many of the prior works have been using a supervised model. When it's up to a binary classification and sentiment analysis, you have large volumes of label data. But when we come to any task which is at the fine-grained level, to get large volumes of label data for a supervised approach is always a challenge. And hence you need to resort to unsupervised approaches. So that is our aim of trying to find out a model for aspect term extraction with minimal supervision. So that's my proposed approach, where I have three different modules initially, which is a pre-processing module, then we have a rule-based model, and then we have a pruning model. So basically my pre-processing model looks at extracting the NER tags, which are the name entity recognition tags, the POS tags, and the grammatical dependencies. So basically for the NER tags, I have made use of the Spacky tool in Python, which is comparatively giving better results. And as far as POS tags and grammatical dependencies were considered, I have gone with Stanford parser, which is one of the best accuracy delivering parsers. So these three outputs in the pre-processing stage are on which my next rule-based module mostly depends upon. So I just gave a glimpse of how these pre-processing outputs would look when applied on a particular sentence. So you see this in a sample sentence given, the POS tag output by the Stanford dependency parser, what are the NER tags pinpointed by Spacky, and how does a Stanford parser identify the dependencies in the given sentence. So moving forward, the second module, which is my rule-based approach, attacks the module in three different levels. That's why I refer to it as a hierarchical model. So I have level 1, level 2, and level 3. The first three rules in level 1 are mostly focused towards identifying two-word aspects, where it could be an adjective followed by a noun or a noun followed by a noun. I also take the help of BIMU lexicon here in order to make good for the mistakes what could happen with respect to POS tagging by a Stanford parser. Again, my next three rules deal with single word aspects. So here, in addition to POS tags, I also make use of the output of the Stanford parser, which are those grammatical dependencies, in order to identify single word aspect terms. So here is an example of a sentence like where R4, the rules R4 and R6 could be applied. So I find out that the word quality has a a direct object relationship with the verb has, and similarly the word price has a adjectival modifier relationship with the word cheap, and that is how I identify that the word quality and prices are aspect terms here with application of the rules R4 and R6. Moving on to level 2, my focus is more on, like for example, they could be like always a rule-based model has the disadvantage that you cannot create or go on creating exhaustive rules. So if I can figure out certain unidentified aspect terms in level 1, can I identify them based upon the relationship with the already discovered rules in level 1? That is the attempt what I try to make out in level 2. So by in terms of conjunctions and in terms of direct dependency relationships with the already extracted terms in level 1, I try to find out if I can find out more aspect terms in level 2. Level 3 is more about, the domains which are laptops and restaurants basically have multi-word aspects, which means aspect terms which are more than 2 words in length. So I just try to make use of proximal indices and try to combine aspect terms with what we have found out in level 1 and level 2 to arrive at multi-word aspect terms. So that completes the 3 levels in the second module, which is hierarchical rule-based module. Then I have a pruning module, which is basically trying to attempt to filter false positive. So that too is designed in 2 stages, which is stage 1, which is based on the pruning the presence of sub-aspects. It can so happen that during a rule-based approach, I can end up as a word being extracted as a standalone term, as well as it being a part of a multi-word aspect. So in that case, I check whether it is created out of a reliable rule, that is based upon an analysis of the trained data. I have arrived at a set of rules which are most reliable in the sense which create least false positives. So if at all that so-called duplicated aspect term is not generated out of these so-called most reliable rules, I would prefer taking them out so that I reduce the number of false positives. Moving on to stage 2, this is an attempt based on the consciousness that whatever be the aspect term that I extract out of the domain, it should have a high similarity with the domain. So basically, I try to extract a set of most frequent aspect terms from the domain, whatever we are working with. And then I try to compute its similarity with the prospective aspect term by using a word embedding model. So basically, I've applied word2vec here, but rather than using the pre-trained vectors, what are offered by word2vec from the Google corpora, I try to train word2vec on respective domains. For that, what I need is large corpora. So I've gone with Yelp restaurant reviews for the restaurant domain, and I've gone with Amazon product reviews for the laptop domain. And hence, I create word vectors using the word2vec model, which are actually more semantically representing their domain rather than generic vectors. So, and then I compare its similarity with the seed words, what I've taken out of the trained data, and I impose a threshold. Usually, the similarity values in the range 0 to 1. I have set a threshold as 0.1. So anything which has a similarity less than 0.1 will be filtered out. So that completes stage 2. So this is an algorithm depicting what we have spoken about right now. And the experimentations are being conducted on SemiVal 2014 dataset, where SemiVal is a semantic valuation series which conducts a series of computations on text data. So they provided labeled data in 2 domains, which are laptop and restaurant respectively, all which are labeled at the sentence level. So moving on to the results of the domain, what I have displayed initially is the level-wise, the results what I have obtained after the rule-based model, after pruning level 1 and after pruning level 2. It's observed that, naturally, the results what I have obtained in the restaurant domain is better than the laptop domain. The reason owing that they were very technical terms in the laptop domain, which goes to the names of operating systems and the names of devices and stuff, which went wrong with respect to POS tagging when it came to Stanford dependency parser. We have acquired around 10% increment by the first pruning stage and around 3% increment by the second pruning stage, with not compromising much on the precision. Basically, we have focused initially on hitting a high recall and then try to prune as much as possible. The second table tries to analyze the results in a different way on trying to understand how much or to what extent have they been able to capture single word aspects, two word aspects, and multi word aspects. Naturally, as the result suggests, they have been better performing on single word aspects, but the performance diminishes when it comes to two word aspects or aspect terms of length of more than two. So naturally, for sure, we should think about improving our model with respect to multi-word aspect terms. Finally, with respect to baselines, I have chosen baselines which have claimed to be unsupervised or closer to be unsupervised. And they also have reported their results in the same semi-val 2014 data set. So the second and the third data lines are projected as hybrid because their strategy has been such that they have adopted initially an unsupervised model and produced pseudo labels. And using the pseudo labels, they have again applied supervised models. So I look upon those models as a combination of unsupervised and supervised models. So that's why I projected them as hybrid. So even though not in par with the most performing model, it has been able to. Have ranked them second with respect to these in comparison to these three models. So the conclusion is that we have been able to contribute an unsupervised model to the largest extent for aspect term extraction, and it has been able to deliver a comparable performance with respect to the state of art. So even though the performance is not great or touching that of supervised models, we can claim that this could be a strong base upon which unsupervised mode, a hybrid model could be built. Or I can even think about exploring other unsupervised strategies and combining them together as a hybrid model. So topic modeling that way is one area what I have in mind for further exploration of unsupervised techniques in this area. And for sure, there should be a huge emphasis on improving the results with respect to multi-word aspect terms. So that's a few references, and thank you. I'm trying to figure out that so-called aspect term what we arrive at should have a minimal similarity. But it could also so happen that the word that I identified is not an aspect term and still it has a similarity. Okay, so that is the reason why I had to bring the threshold to a minimum. So my threshold only ensures that aspect terms which are not at all related to my pruned out aspect terms which are not at all related to my terms get filtered. Okay, so because that is our notion. Eliminate terms which are not at all related to the domain. Because this approach is based on similarity with the domain, which will help me only do that. That part was completely mine. And doing it on a trial and error basis was completely mine. So I'm ready to not my data set for evaluation is semi-math but I'm creating word embedding vectors by training it in the respective domain. You see, my semi-val data set is one on laptop data and one on respective. So I need similar domains to create word embedding vectors. So Yelp data set is Western. So that is why I'm creating word embedding vectors for Western data set by training it on Yelp. But probably I tried low and low, but not low. Probably I could experiment with both now and see. In fact, I was not really happy with the printing results what I got from the second printing stage. Okay, so probably better word embedding models will produce better. It could be any domain or it could be any data set based domain. Okay, so that's because semantic similarity is more reflected when you are training it on that particular. So basically, I'm not constraining my model because the so-called Delphi review or Amazon review, what I'm going to be unlabeled. I'm not touching the label in that data for training. Basically, word embedding models are unsupervised. So I don't challenge somebody by providing or enforcing the condition that I need supervised or labeled. Unsupervised data is always easy to do. Okay, so that is the reason why I got reference reviews which are quite large. So we could challenge what we have is that the data should be quite large when you are training using a deep learning. So that way, I just identified Amazon reviews which are electronic clients. So I couldn't get laptop alone with fine. So I thought I'd take the entire electronic device. But for SPN, I got a data set quite around 1.5 Kelvin. That's how I yeah, there is a little bit of domain specificity coming there, but that adds to my result because ultimately, however, you say domain independent model you are targeting, there are certain semantics which are reflected only when you do domain related or domain specific. Not experimented to find the boundary. Basically, it's all every review would be scanned only once. Every sentence. Because I the basic copy sheet gets over with native making the output. I mean, I calculate my complexity in terms of the output. Probably Stanford Parser or has a high complexity. But I'm not analyzed into value. So, and you learn from unmade data. In the sense, yeah, for example, word agrees, and then this so-called rules. When I said that one of the rules pages that I did, basically all these rules have been basically a people who takes care of removing one of the reasons why
Thank you, ma'am. Moving to number 5. Network Status Aware Congestion Control NSACC algorithm for wireless body area network.
And myself also came from IIITM-Kerala. For understand one thing, I cannot rotate my head. I only understand. I have a problem. Someone may have about first thing, my topic, the paper is on network status, web condition control algorithm for wireless communication networks. So I'll tell about this. First, I want to acknowledge my guide, Dr. Dean. We'll go into the outline and we'll discuss these topics. There will be introduction, motivation, deliverables, proposed lessons, clarity, results, and differences. I'll give a gist of my presentation before going into the slides. It's regarding the wireless body area networks. In that, I want to go into the concept about condition control. So, as the wireless body area network is most necessary in these days, why? Because a patient cannot reside always in the hospital. Now, everyone have a necessity to attend to any urgency, or he may want freedom. So that's why in some cases he may not be in hospital. So a patient may get freedom to roam anywhere, and he will be covered with a wireless body area network, and it's a tiny network. So that should be communicated through internet to the hospital. So this is my point. So this network is dealing with the health monitoring of the patient. That's why this is emergency aware. So as this is emergency aware, the condition should not occur and the transmission rate should not come to zero. So that's why I focus on the concept of condition control. Okay. So I'll introduce the wireless body area network. It's a standard number of IEEE 802.6. It is after the WPAN. That's standard number is 802.15, 15.5. This is regarding, it's a tiny body area network that covers the human body, and in that the sensors and actuators will be implanted. So the sensors may be implanted in the skin, or maybe along the skin, or outside, or on the body. So on the body means the sensor can be kept inside a port or in a pocket like that. So all these sensors will sense your body, and they will send information through a gateway. So So that's nothing but your tablet or a phone. So through the gateway, it transforms to internet and it reaches the specific organization at Ultimate Hospital. Right. So when it came to the applications, we are discussing about the healthcare and also it can be used in sports, entertainment and more. So what are the challenges in WBAN? If you see the first line, the condition is the severe challenge, and the next one, limited bandwidth, low power devices, security. So all these problems are coming with only the problem that is a tiny devices and low power devices. So this is only the basic cause. So basic cause is the third one, low power devices. Okay. So with condition, if you go to the first line, with condition, we are facing the problem of packet collision. And with limited bandwidth, in this tiny network, there will be a very limited bandwidth. With that, the transmission rate will become zero. We cannot transmit much more amount of data in a specific time. And low power devices, due to the low power devices, the battery may discharge soon, and if the number of retransmissions are more, the packet retransmissions are more. And also, it may get hit. So all these are problems. And also security will be very less. So there is no firewalls or proper firewalls designed for this. So all these are the challenges. I focused on the first problem, that is condition. Right. More into the detail. So what is the impact on WBAN? So it affects the end-to-end reliability and the quality of service of this WBAN and the security effects. So like this, it impacts, the challenges impacts the WBAN. And these are some related works I presented. One is that I selected from IIIT student like qualities papers only. And I compared my paper with the first one, that is PCC2, and it's an IIIT conference. So I go into my related works continuation now. Okay, so what I observed from the related works, what is the problem in that? Okay, so existing solutions, when the condition came, existing solutions giving the transmission rate almost to zero. So all we must know the slow start method. The slow start method, it increases slowly, and after that it increases exponentially, and it crosses the bandwidth which is available. If it is sending more packets than the buffer or the queue, then obviously the collision packet loss will occur. So if the packet loss will occur, then they are taking the solution that they are immediately taking back the transmission rate to zero. So in this emergency, there the point lies in for this paper. So if it comes to the zero, if a patient is in an emergency condition, his heart rate is very abnormal, he should get immediate response from the doctor wherever he is. Then what happens? If the transmission rate comes to zero, it cannot send the information to the hospital, and from that you cannot get the response. So that is the severe problem. There we are getting that if the transmission levels are coming to zero. So for this, I give an exact solution. I'm not dropping to the zero levels, and I'm not exponentially increasing my transmission rate from the beginning. I'm taking the logarithmic approach of transmission. So if you go into the mathematics, the logarithmic increase will increase in the first, and thereafter it takes a curve and it sustains for the long time. So I took that sustained period before to the condition occurrence level. That's why it doesn't go to the condition state immediately, and also after condition occurs, when it finds, it doesn't come to the zero levels. It comes to the half. So all these things were explained better in a very simple algorithm which I proposed. So what is the need of this? I explained this. WBAN applications cannot tolerate the transmission rate to become zero as they are emergency aware. For example then. Okay. So, what should I do? Then my algorithm comes into the picture, that is the proposed NSSCC algorithm. So overall observation is the problem is started with condition. So my objective is to avoid the condition. So for that, avoiding the condition, my algorithm contains the two modules. The first one is CIM and another one is RR module. The CIM is a condition identification module. It identifies the fuzzy network, fuzzy base rules, and then RR module is a rate regulation algorithm which regulates the transmission. If we go to that, so what to attain with my NSSCC algorithm? So to attain lower number of packet drops and lesser number of retransmissions and more throughput. So everyone wants more throughput with lesser number of retransmissions. That is nothing but packet loss. Packet loss should not occur. So these are the two modules I propose: condition identification module and rate regulation. So condition identification module, it conveys the severity of the condition. So here in this module, I specified some levels: condition level 1, condition level 2, condition level 3, condition level 4. These are better used in the implementation of the RR module. That's nothing but this algorithm. You can see in this algorithm, you can observe the parameters like CL1, CL2, CL3. So these are the condition levels I defined. Based on those condition levels only, I made it. So you can better understand this algorithm. This diagram. So before that, I show. So this condition can be identified with the buffer occupancy level, packet arrival rate, and priority of the sensor. So by using these three parameters, we can calculate the condition level. Right. We'll go through this algorithm. In the first line, we have a condition. We define a condition level 1, and the second if case there is a region between CL1, CL2, and the third one CL2, CL3, like that. Okay, so all these are explained with this simple diagram. You see in this, the first if case, it sharply increases. If you observe the formula, NR is equal to NR plus N into log N base 10, log N power N minus P of base 10 plus NR into NTR. So if you observe the second line, there is no power to the log N base 10. So there itself, you reduced the transmission rate. That is the second one. And if you go into the third condition, the third term is missing. So again, the transmission rate is slightly diminished. Not it is going aggressively. First it is sharply, and in the third, the third arrow, you can observe the maximum transmission is stay in that period, so that it is not entering immediately to the condition state. So whenever at the if case, if NR is more than CL3, so CL3 is the condition level. If it is more than the condition level, it should drag down the transmission rate to the half, not to 0. That's what I explained here. There is a sharp one, but it's coming to the half. By this, I achieve better results like throughput and packet loss, number of retransmissions. We observe here is a graph. The blue lines indicate the proposed NSSCC algorithm, and the red line is a PCCP existing algorithm. So here we can clearly observe that it is having it approach, you get a better result than PCCP. Also, you can observe when we use a single sensor on a wireless body array network, and if we use the 5 sensors on a body array network, you can observe these in this If you, in the case one, you can observe, if you use a single sensor, the PCCP is achieving 15.5 and NSSCC that is proposed is achieving 27. So it is a better result when compared with the existing algorithm. And the case 2 also is achieving the better results than PCCP. And the average packet loss is also very less because the transmission rate is good and there are no collisions in condition. That's why average packet loss is less and number of free transmissions are also less. So this overall summary is that finally I achieved a better throughput, better delay is reduced, and the number of retransmissions are reduced, packet losses. Thank you all very much. As is my first dedicated presentation, if there are any first point. Any questions? Yes, please. Initially, I considered I took a basic scenario of slow start algorithm. So that slow start algorithm, whenever it's whenever a condition comes, everything is coming to zero in that case. And also, when I observed with the existing algorithm, we also driving down to the zero. So the fact is that what I observed is in a healthcare, every packet in all the times it is necessary. So we cannot predict the health situation or health condition of a human. Why? Because I am not only motivated to discover that for the last some 6 months or 8 months. Before 3 years ago, my mother went through a heart attack. So if she had a sensor with her, that can immediately raises a red symbol or an alarm in hospital or a particular doctor. And the doctor may give an immediate prescription or he may call to her phone. So fortunately, my dad is listening. She's in Germany. So almost she started from the source. She had to travel around 600 kilometers. There she is doing job. And she went. My parents went almost 100 kilometers. So at that situation, the heart attack, the first stroke came. My dad immediately took a cab and went to the hospital. All the things. And also, I'm also suffering with problem for the past 10 years. Like that, I motivated much in this public and the services of health should go to everybody. Maybe it comes to the implementation like business, it comes into the business. It may cost for the first 1 or 2, 3 years. But after that, a normal guy also can have it. Normal people also can have it. That's why I want to contribute my works on WP. Yes, yes, yes. There are, I planned some other approaches also. Because in all the cases, the problem, the immediate problem which raises is sending lot of data, lot of information is another problem. That is the major problem. So those are tiny devices and they have a very less memory and they cannot store memory. So if they keep on sending, the battery may dry out or it may get used. So due to that, some the lifetime of the W band may come down. So these are some challenges. Thank you.
Thank you. Moving to the sixth presentation, Adaptive Cubic Spline Interpolation in CI Lab Color Space for Underwater Image Enhancement. Good afternoon, everyone. My name is Deepthi. I'm from KLE Technological University. I'm here today to present my work on adaptive cubic spline interpolation in CI Lab color space for underwater image enhancement. Part of this work was done during my internship at IIITM. Okay, so just an outline of the presentation today. We'll start with the motivation. Okay, so underwater imaging has a broad variety of applications from marine habitat mapping, simultaneous localization and mapping, and the visual study of marine life. So computer vision has come out with a lot of advanced algorithms for recognition, segmentation, and overall scene understanding from images. But due to the nature of underwater imaging, these techniques are limited by the quality of those images. Okay, so these are some examples of ideal underwater images, right? So if you've seen any ocean documentary or if you've Googled any underwater plant, this is the kind of image that you would expect. All the colors are retained. There is clarity in the image and overall good quality. But when we're dealing with less expensive camera equipment, with ambient light, with a single source from the camera and a single monocular imaging structure, these are the kind of images that we have to deal with, right? So you can see the drawbacks of dealing with this kind of images. So you're dealing with haze, color distortion, blur, and an overall blue-green tint, which results in a loss of a lot of the information of image feature information. There's low contrast and lots of noise. This also results in poor reconstruction of 3D models. So a popular method of reconstructing 3D models is through structure from motion, right? So the main limitation of structure from motion is that it depends on the nature of images and how they're captured. So with these, the types of features that these underwater images have, it results in poor SFM reconstruction. Okay, so first we'll look at the related work and the background. So we're going to be talking about the related work of mainly underwater image enhancement. Okay, so first is straightforward image dehazing. So haze is the main aspect which results in the poor quality of these images. Haze is a depth-dependent image feature where the features are obstructed by a cloudy, a kind of cloudy nature with increasing depth. This is due to forward scattering of light from minuscule particles in the water. So dark channel prior is a very popular image processing technique for above water haze, so terrestrial haze. In normal images, if you take a picture of a city skyline, the buildings far away can seem hazy because of smog and fog and all of that stuff. So these dehazing techniques are applied for underwater images as well. But due to the nature of the light attenuation and the inherent differences of how images are captured underwater, this fails and it results in color distortion and not a lot of the haze is removed, as can be seen in the results of the paper of Satya et al. Okay. There are also obviously deep learning methods. Deep learning finds its way in every image processing application. But due to the nature of the data of underwater images, a lot of deep learning models fail. So when we're talking about applications such as classification and recognition, there are a lot of available, really robust data sets which are labeled very properly and which give really good results. But The underwater image data sets are often a result of web scraping or collection from a lot of different data collection agencies, which do not publish the way that they collect their data. And resolution is different, the size of the images are all different. So because of this less amount of data, you get overfit models and models that aren't representative of underwater images. Okay, and one particular really popular deep learning model as of late is GANs, right? So we generate underwater images with improved quality, but again, GANs result in low resolution images that still have unsatisfactory quality. So you can see the results of GANs here. So these images are pretty low quality, like 500 cross 500, but in applications such as habitat mapping and the use of these kind of enhancement methods for scientific uses, we require extremely high quality images with faithful representations of color and structure. So this is still a problem that deep learning models have not been able to resolve. Okay, so a bit of background on the approach that we propose. So we work in the CI lab color space, which is based on the CI XYZ color space. So the reason we use this is because CI lab is extremely representative of how humans see color, right? So when we're talking about image enhancement, we want it to look pleasing to the human eye, and we want it to look like an above water image. Okay. Okay. So first, and then I'm going to outline our proposed method. So it's a basic flow diagram. First, we start with contrast-limited adaptive histogram equalization for increasing contrast and reducing the haze. And then we take care of the color distortion and the blue-green water tint by using adaptive color curve estimation, which I'll get into detail a bit later. And then once we estimate the color curve, we remove the water tint. Okay, so this is an example of the color curve that I'm talking about. We chose an empirical value of 10 knots, which represent the different color levels in each A and B channel. In the CIE LAB color space, L refers to the luminance, which we don't touch. So luminance is just for the histogram equalization and the structural improvement. When we deal with the A and B channels, we're talking just about color enhancement. So this is on the left, you can see just an example of a color curve. So this center curve can be changed in any shape or form, controlled by these knots, C0 to C9. And this is an example of a color curve which has been estimated of my underwater image. So if you can see an underwater image here. So the first one is, both of these images are, have undergone histogram equalization, but you can still see that when you look at the A channel, it's still, off center and leaning towards the left. That means that the overall color space and the color features of this image have a blue or green tint. So what we want to do is remove that blue or green tint without losing the color information of the underlying object, right? So if we have a blue fish, for example, we don't want to wash out that color by taking out the blue background. So the main idea is that we aim to get all of the bins in this A channel at a neutral point. So after the color curve is estimated, so this color curve on the right is the estimated color curve for the blue image that I showed you. So once that color curve is estimated and corrected, the histogram results in this sharp point. So we perform our process until this all the image histograms look like this, and this is the color corrected image. Okay, so I'll walk you through some qualitative and quantitative results of our methodology. Okay, so these are the qualitative results. So it's an you can see this is the same image as shown before, but this time you can see that there are still blue objects in the image, and the colors have not been washed out, but the contrast and the haze, contrast is improved and the haze is improved. So these are another few examples. Okay. And this is a comparative analysis with a lot of the state-of-the-art methods for enhancement. So this is the original image in the first column, and the next is just simple contrast stretching, which does not solve the haze issue. And this is Ankuti, Berman, and Berman. So there are a group of image processing research groups which specialize in underwater imaging, and a lot of the state-of-the-art stems from these papers. So you can see in the last column, our results are extremely competitive with these previous results. And this is just a continuation. So the the methods that we're comparing against are the same. It's just a whole scene instead of these color charts. And one thing which I'd like to point out, the methods of Berman and Berman, the 2 years that they have demonstrated results, they are dependent on transmission maps, which is a result of a depth map and the haze map, which is combined to give a transmission map. So a lot of the enhancement methods are limited by the quality of the depth map that they're able to estimate from their underwater image. Okay, so these are, this is a color chart where you can just see the none of the colors have been distorted and the original colors are retained. And this is a quantitative analysis. So a main challenge with underwater image enhancement, quantitative analysis is that we don't have a ground truth. Right? When we're talking about enhancements like super resolution or noise removal, we have a ground truth usually, and we can calculate PSNR, and it's a pretty standard method. But we can't lift the scene out of water, and we don't have a ground truth for that. So we have to use single image reference-less quality metrics, which are flawed. They're not perfect in estimating quality, and I'll explain why. So these two methods, one is BRISC, in which a higher value indicates a lower quality of the image, and another is UCIQE, in which a higher value indicates a better quality. So BRISC is a really popular single image reference quality metric, but it's not specifically for underwater images, right? So the way that images are formed underwater is completely different than they're formed above water. So when we apply, terrestrial quantitative methods for underwater images, we get a certain level of error. With this next UCIQE is calculates quality by calculating a weighted sum of various image features such as contrast level and so on. But this is easily manipulated. So if you have an image with extremely high contrast, you will get a very good UCIQE value, but at the same time you might get color distortion. So it doesn't measure how faithful your underwater image is to the original image. So for that reason, we used a combination of several methods. CL is just contrast luminance. So contrast luminance is again another factor in UCIQE. That's just a weighted sum. So in red, the red value indicates the best value in that comparison. So you can see that our method performs the best in, for image 4, which is the images which I showed you in the previous slide. But it does get outperformed by certain, images in certain places, like in UCIQE performs better for image 1. But it's definitely competitive, and we're still searching for a more comprehensive quantitative analysis. So in summary, we tried to solve the problem of distortion, color distortion, haze, and the presence of water tint in underwater images for improved underwater imaging tasks like recognition, segmentation, and all of that. And we proposed an adaptive color corrector using cubic splines, which is the color curves which I mentioned before. Yeah, so in future work, since this is an image enhancement model, it's not an ideal image restoration model. So when we're talking about scientific applications, we want to justify the restoration with an actual physics-based model and an inverse equation. So what we propose is that this serve as a post-processing module just for any remaining water tint that remains in the image. So if this acted as a post-processing step in a larger pipeline for underwater image restoration, that would result in even better results. And also we did not focus enough on haze removal for our image, which there's definitely scope for improvement on haze removal. That's it. Thank you. Yes, see-through. So that paper took like the underwater imaging world by storm. So I'll tell you the difference with see-through. So see-through is first not a single image restoration model. It depends on if there's an underwater scene. It takes around 60 to 70 images of that same scene, and it reconstructs a depth map through SFM. So they have an extremely accurate depth map down to the pixel. And there's an image restoration model. So there's something called the image formation model for underwater images, which takes into account, which physically models light attenuation, backscatter, and a lot of different properties. So what they've done is they've done an exact inverse operation. So there is like a one correct answer in a sense. So if you have an image and there's a bunch of exponential terms multiplied, a bunch of additive signals added to that, they're finding the inverse. So what we're doing is image enhancement, which isn't really following an inverse mathematical equation. It's making it look more visually pleasing. So yeah. Yeah. So that's kind of what I was saying. Like, if you have fog, so I'm assuming you're talking about like a picture of just a normal picture, not an underwater picture, right? Yeah. So that would be different because the way that the image is captured is completely different. Like, for example, haze is depth dependent in above water images, but it is not channel dependent. And how I mean channel is each channel corresponds to a color, and when I say color, I mean wavelength, right? So each color is attenuated roughly the same amount. But in underwater images, haze and color attenuation is channel dependent or wavelength dependent. So the way that we have to think about our image enhancement models is different from above water. So like when I showed this result, so before people tried to kind of generalize dehazing for underwater as well, and they didn't really succeed for that. No data set as such. It's not a training-based model. It's not data set dependent. But yeah, we worked with around like 600, 700 images. Something very, it's not a deep learning-based model. So yeah, so I have a quantitative. So this is comparative evaluation. So I have my original image and I have these quantitative quality metrics, which give a numerical value of corresponding to image quality. So a brisk numerical value, it ranges from, I believe, about 0 to 100, with lower value being better, and with UCIP higher value. Yes, it's it's cubic spline interpolation. Yeah, it's cubic spline, polynomial cubic spline. We're actually not losing color information, but it's hard to definitively say we're not losing color information. But you can see in this result that the color of the fish and the reefs are a red fish. And in other images, yeah. So the color palettes represent how much color is being lost. You can, if you look at the color palette. So yeah. Thank you.
Thank you. And moving to the last presentation, an end-to-end model for detection and assessment of depression levels using speech.
This is Sri Madhu from Andhra School of Engineering, Bangalore. I have done this research work under the guidance of S. Lalita. My research work is end-to-end model for detection and assessment of depression levels using speech. These are the table of contents I am going to discuss now.
thing is like depression. It's a physical disorder identified by an extensive and continuous low mood actions, which can lead to the, if it becomes very severe, it can lead to the like addictions and without any interest, it affects his personal and his work life, and it even leads to the suicides. You have been seeing in the news like so many people are committing suicides due to the depression they are facing it. And it's a main cause for more than almost two-thirds of suicides in the world. And present existing diagnostics are mainly based on the verbal reports of the patients, which are like after the doctor consults with the patients, like they'll be interviewing the patients. So based on their answers, doctors are deciding whether they are depressed or non-depressed. And after that, like so many biological markers were also used for detecting the depression. Like it's having patient is having a low serotonin levels, or even no biomarkers are reported, then it can be decided as like he's depressed. And other methods like using speech features, like temporal features, spectral features like speech rate and articulation rate. These are the different features which are used for classifying a particular person as a depressed or non-depressed. These are body and facial expressions and ideal-based depression techniques. In ideal-based depression techniques, like if we say mean distance between the two eyelids, if it is low, or the mean rate of this blinking rate, if it is low, means it can be decided as like a depressed. These are the general approach for depression detection system. First is the pre-processing, where the silent regions are removed from the speech, and only speech regions are sent to the remaining process. Then is feature extraction. There are different features, spectral features, temporal features, and energy, form and frequencies like F0 and MFCCs, rate frequency quotients are extracted. Then manually they are taking the more descriptive features. Then they are giving it to the classifiers. Classifiers like SVM, support recognition, and GM and Gaussian mixture models are the different classifiers used for the classifying the features. Our objective is to detect the depressed state using the raw speech signal as an input without extracting like separate modules for the feature extraction and classification. We are directly giving the raw speech signal to the system model. It will detect whether person is depressed or non-depressed. That is our objective. Related works on this depression detection are: first one is study of acoustic features for classification of depressed speech. In this, extracted from energy features MFCCs, then they are given it to the ACN model. This is of 70%. Second paper is deep audio network. Here, MFCCs and spectrograms are extracted from the speech signals, and they are given to the deep learning model, convolutional neural network model. And this model, it has extracted the discriminative features from the spectrograms and MFCs and classified the speech into the depressed or non-depressed. They have achieved F-score. They have measured their performance using the F-score. They have got like 0.52 for depressed and 0.7 for non-depressed signals. Next is detecting depression in speech, comparison and combination between the different speech types. Different speech types, it's like by taking the interview or through the reading, they will be giving some paragraph, and this patient will be reading that paragraph. And one more thing is interview, read, and through the expression. Like if the picture is given, so they will be asked to describe that picture. So based on these features, like these are taken as the speech signals. And here the features they are extracted on this thing, energy, MMC, same features only, like the previous paper. And the classifier they have used is support vector measure, SVM. They have achieved 77% accuracy in this but then is read and spontaneous features. It's like read this, they will be giving some passage and they will be reading it. And spontaneous means they will be asking the questions spontaneously. So based on their answers, they have taken those samples for the this classification. Here they have used temporal features like articulation rate, speech rate, and all. And the classifier used is SVM. The main shortcomings of these existing works are most of them are picking the hand-picked features for the classification. Like they are extracting the features, but the more discriminative features they are picking it manually and giving it to the classifiers. And so it requires additional classifiers for the classification. And one more thing is it's our speaker and language dependency are there in the previous works. So if if the patient is male, we is getting the different results than the female. And other thing is different languages. Because they are coming from the glottal feature, like glottal tract, they are extracting the speech signal features. So that's why it will be different for different languages and the speakers. So our proposed method is this thing. We'll be going in depth in the next slides. First is database preparation. I have used AVEC 2016 type WOZ. AVEC means Audio Visual Emotion Challenge. It's developed by DeWalt in 2016. What they have done is they have interviewed the different patients and they have got the responses from them. Those are taken for the further research. Here you can see it's the key results for non-depressed and depressed. In what thing I have analyzed from these things raw speech is, in the depressed, the most of the intensity levels are concentrated at the particular time instances. Whereas in the non-depressed, it is spread towards for the full duration, then energy levels. And one more thing, like in the AVEC database, there are total 189 participants they have interviewed, out of which 146 are non-depressed and 43 are depressed. So as a deep learning model needs the more number of samples, so what I have done is I have segmented each speaker's voice into the multiple samples of 7 seconds duration each. And total samples I have collected is 1107 for non-depressed and 1133 for depressed patients. This is just to balance the samples, otherwise the biasing will be there. So that's why I have done this here. This is the first model, spectrogram based convolutional neural network model. Here I have extracted the spectrogram of the speeches. Spectrogram is with time with respect to frequency of the short-time Fourier transforms. That is given to the convolution layers. What this convolution layers does is, you can see like 4 convolution. 4 means 4 kernels of sizes of 3 by 1, 1 by 3 and 3 by 1. So actually the first layer is 3 by 3. I have put it wrongly. So it's a square matrix, square kernel. Other things are horizontal and vertical edges. What this does is we will give this spectrogram to this model, and this kernel travels over all the samples, and it will detect the different patterns like horizontal edges, vertical edges, or it will smoothen the image to find the higher frequency components of the speech. And these forms the activation maps. These are given to the flattened rail. What it does is it will transform the
by 2 matrix into the double matrix into the row. That is given to the dense layers. What dense layers does is it will first generate the classification. It will classify one thing, and based on the error, like it is between the actual sample and predicted sample, it will generate the error. To reduce the error, it will back propagate it and updates the weights of the kernels. These are the things done by the dense layers. This can be this I will be explaining how like updation of weights done in the next slide. This is the another model I have proposed, end-to-end convolutional neural network model. In the previous model, we can see like spectrograms are extracted from the speech and given to the model. Here directly I am giving the raw speech signal to the model itself, convolutional neural networks. Here, as the speech is the one-dimensional signal, I have taken the kernels of one-dimensional signals of 64, means 64 samples for the kernel, and in the next stage I am increasing the samples, number of kernel size. The same thing happens, and it will generate the depressed or non-depressed. And max pooling I have used just to reduce the dimensions of the activation map. What max pool does is it will take some filter size, and what is the maximum value, it will take it as the in that thing, and so that it will reduce the dimension. That's it. This is the process for back propagation and convolution for weight updations. First thing is, of the dense layer output, it generates this thing, summation of the weights into the activation function plus some bias. So this is the mean square error. TP is the true prediction value, whereas AL is the predicted value. It will generate the error and it will back propagate. And this partial differentiation with respect to weights, it generates some, and finally we get this dou E by dou Wx equal to this equation. Based on this equation, it will update the weights. This is convolution only with respect to weights and the activation functions of the next layer with respect to this present layer. So that it will update the weights of each kernel. These are the results. These are the spectrograms for non-depressed and depressed. You can see like for the non-depressed, energy is spread over the duration of the signal, whereas for the depressed, it is spread mostly concentrated at the particular intervals of the time. This is the same as I have discussed in the raw speech signal. And these are the comparisons of the results for the two models I have proposed. First is spectrogram and the end-to-end model. You can see like I have measured the performance using the recall, precision, and F-score and accuracy. Accuracy is nothing but like number of correctly predicted values by the total values, predicted values, and whereas recall, precision is the total true positive, this is positive rate, means positive samples predicted divided by the total number of samples, whereas recall is the actual true positive rate, that is true positive samples divided by total positive samples. So I have measured the performance using these metrics. You can see end-to-end model is performing better than the spectrogram-based model for all these parameters. This is for depressed and non-depressed states. And this is the comparison with respect to the previous works. That is, one is CoCoNet' and Adabu's framework and collaborative representation. I have taken only these papers for comparison just because they have done this research on the AVEC dataset. Remaining works are all done on the different datasets. So you can see the improvement in the performance of the proposed model with respect to previous works. There is almost there is almost like improved performance of accuracy by 8%. The accuracy of this ADABUS framework is 66%, whereas the proposed method got the accuracy of 74%. And for the other metric, that is F score, there is improvement by the 19%. Sorry. With respect to the ADABUS, whereas ADABUS generated a 59% of F score, whereas the proposed method got the F score of 77%. And this is another thing I have proposed. Like previously, I have just classified into the depressed or non-depressed, but here what I have done is I have classified into different levels of the depressed state. For this, what I have done is there is a PHQ-8 score generated for each patient in the AVEC dataset. So if it is score is less than 10 means they are classifying it as non-depressed. If it is more than 10 means that is depressed. So PHQ-8 score of 10 to 13 is I've considered it as first stage of depression, then 14 to 16 as the intermediate stage, and 17 to 20 as the final stage of this depression state. So I got these are the results I got for this proposed method. You can see that performance is good for non-depressed and depressed state, whereas for other stages the performance is very poor because the data samples I got from the data set are very less for that intermediate stage and final stage. Then this is the conclusion. The future work involves the optimization of the model through the selection of the best subparameters for the convolution layer and max pooling layer. And another thing is we need data sets from the different languages so that we can build a model for language independent model. And another research area is multi-stage convolutional neural networks. Here they can take like different resolutions of the time in time and frequencies. So that is given as the input to the convolutional neural networks, so that it can learn the more descriptive features from the speech. So these are the future works that can be done on this area. These are the references.
Hmm.